Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic today and it's on linear equations and linear inequalities. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to solve linear equations with one variable. You should be able to solve word problems involving linear equations with one variable. You should be able to solve linear inequalities with one variable. And you should be able to solve word problems involving linear inequalities with one variable. So let's begin with the first part of our topic, which is linear equations. Linear equations. Now, what is an equation? An equation is a numerical statement which involves the equal sign. An example is 3x plus 4 equal to 10. Now we can see that we have this expression on the left hand side and this expression on the right hand side. So here we have 3x plus 4 as an expression on the left hand side. Then we have 10 on the right hand side. Now immediately you bring an equal to sign between 3x plus 4 and 10. We are saying that the whole thing turns into an equation. So this time 3x plus 4 is equal to 10. The expression on the left hand side is being linked to the expression on the right hand side by an equal to sign. So whenever you see any mathematical statement or any numerical statement which involves the equal to sign, we call that statement an equation. So 3x plus 4 is equal to 10. Because we have an equal to sign in this statement here, this whole statement is called an equation. So equation from the equal sign that we have here. So you have equation here, which means that it involves the equal sign or the equal to sign. I hope that is clear. Let's consider another type of equation or another example of equation. We have 5a minus 1 is equal to 7b. So in this case 2, we have the expression 5a minus 1 on the left hand side. We have the expression 7b on the right hand side. Now 5a minus 1 is linked to 7b by the equal to sign here. So the whole expression, which is 5a minus 1 is equal to 7b, is called an equation because we have the equal to sign in this statement. In the same way, x squared minus 4x plus 3 is equal to 0 is also an equation because we have x squared minus 4x plus 3 being linked to 0 by this equal to sign here. So this is called an equation. Another example of an equation is y exponent 3 plus 2y exponent 2 minus y plus 3 is equal to 5. So in this case 2, the expression that we have on the left hand side, which is this, is being linked to 5 by the equal to sign. So the whole statement here is called an equation. So we've seen what an equation is. Now, what is a linear equation? An equation is linear if the highest power of the variable in the equation is 1. Now, what does this mean? We have this here, these terms here, you are going to explain them. Highest power and variable. Now, let's begin by explaining variable. We learned from algebra that we have variables and coefficients. So, for example, in this equation here, we have the term 3x. Now, because x is a letter that keeps on changing, s can be a lot of numbers. S is called the variable because it varies, it changes. Here we call 3 that is attached to s or the number attached to the variable, the coefficient. So in this equation here, s is called the variable or the letter in the equation. Now, so we've seen what a variable is. Let's move on to the next term, which is the highest power. We learned from indices that if we write a number, say 2 exponent or 2 with 5 on top of it like this, we call 2 here, we call 2 as the base and 5 as the exponent, the power or the index. So 5 here is called the exponent, the power or the index. So what this term means is that if an equation is linear, the highest power of the variable in the equation must be 1. Now let's come here. We know the variable. What is the power of the variable in this equation? The variable in this equation is x. The power of x is 1. We know that any number raised to the power 1 is the same number. So x raised to the power 1 is x. So whenever you see a variable, a letter with no power on top of it, it means that the power there is 1. So it means the power of x in this equation here is 1. So if the power of the variable in an equation is the highest power of the variable in the equation is 1, the equation is said to be linear. So when you come here, the only variable we have here is x, and the power of x here is 1. Which means that the highest power of the variable in this equation is 1. So this equation here is a linear equation. I hope that is clear. Now let's come to the second example. We have 5a minus 1 is equal to 7b. We have two variables here. Now let's look at something. The power of the variable a here is 1. The power of the variable b here is also 1. So here, the highest power of the variable we have in this equation here is 1, because the power of the variable a is 1 and the power of the variable b is also 1. So because the highest power of the variable is 1, this equation is also a linear equation. Now let's come to this example. The variable in this equation here is x. Now let's look at something. The power of x here is 2. The power of x here is 1. So in this equation, x has two powers. It has the power 2 and the power 1. Now between 2 and 1, we know that 2 is the highest. So when you come to this equation, we say that the highest power of the variable, which is x, the highest power of x is 2. Because when you come here, the power of x here is 2 and the power of x is 1. So the highest power is 2. Now because the highest power is 2, this equation here is not linear, because the point says that for an equation to be linear, the highest power of the variable must be 1. Here the highest power of the variable is 2. So this is not a linear equation. If you watch the video on quadratic equations, you will see that this equation here is an example of a quadratic equation. Let's move on to the next example. The variable we have in this example here is y. Now, the power of y here is 3. The power of y in this term is 2. The power of y in this term is 1. I hope that is clear. So what is the highest power of y in this equation? The highest power of y in this equation is 3. So we have power here 3, power here 2, and power here 1. Now 3 is the highest. So the highest power of the variable in this equation here is 3. Now because the highest power of the variable in the equation is 3, it is not linear, because an equation is linear if the highest power of the variable in the equation is 1. Now because the highest power of the variable in this equation here is 3, it is not linear. So we've seen that this is not linear. This example here is not linear. In the same way, this example here is also not linear. This is an example of a cubic equation. In this video, we are going to concern ourselves with linear equations. Let's move on. The process of finding the value of the variable in the equation is called solving the equation. Now, what does this mean? When we come here, we have seen that this example here is linear. This is also linear. So we are going to concern ourselves with these two examples from now on. So we are going to concentrate on this one and this one. Okay. The point says that the process of finding the value of the variable in the equation is called solving the equation. Now when you come here, the variable in this equation here is x. The process of finding x in this equation here is referred to as solving the equation. So when a question tells you to solve an equation, what it means is that find the value of the variable in the equation. In the same way, when we come here, the variable in this equation here is a and b. So the process of finding a and b is called solving the equation. I hope that is clear. So when a question tells you to solve an equation, all that it wants you to do is to find the value of the variable in the equation. So here, the variable is x. So if the question tells us to solve this equation, what it means is that find x. Here, when the question tells you to solve this equation, what it means is that find a and find b. I hope that is clear. Okay, let's move on. Linear equations have only one solution. Now what does this mean? We know that this equation here is linear. Now because this equation here is linear, what this point is telling us that when you find x, you are going to get only one answer for x, or only one value for x. When you find x, you are going to have only one solution because this equation here is linear. In the same way, 5a minus 1 is equal to 7b is also linear. So if you're able to find a, you are going to have only one solution. If you're able to find b, you are going to have only one solution. But because x squared minus 4x plus 3 is equal to 0 is quadratic, because the highest power of x there is 2. Because this equation here is quadratic, if you find x, you are going to have two solutions. X is going to give you two answers. Once again, if you watch the video on quadratic equations, you will see that when you find x in this equation, here, you are going to have two answers for x. So here, you are going to get x is equal to 3 and x is equal to 1. If you watch the video on quadratic equations, you understand how that solution is done, or how solving quadratic equations is done. You are going to have two solutions because it is not linear. For linear equations, you are going to have only one solution. I hope that is clear. Now let's move on. In the same way, if you solve for y in this equation, because the highest power of the variable is 3, and this is an example of a cubic equation, if you solve for y, you are going to have three solutions, three different values for y. So here you are going to have three different values for y. When you solve for x, you are going to have two different values for x. In the same way, when you solve for a here, you are going to have just one solution because this is linear. When you solve for x here, you are going to have just one solution for x because this is also linear. Now let's look at something. We've seen that this equation here is linear. This equation here is also linear. But even though they are both linear, you can spot some difference. Here we have only one variable, which is x. When you come here, we have two variables. We have a and b. In this video and the subsequent ones, we are going to concern ourselves with solving linear equations that have only one variable. So in this video and the next, we are going to consider solving linear equations of this type, linear equations with only one variable. If you want to understand how to solve linear equations with more than one variable, watch the video on solving linear equations, solving simultaneous linear equations, or solving linear equations simultaneously. If you watch the video on solving simultaneous equations, you understand how to solve linear equations with more than one variable. In this video on linear equations, we are going to concern ourselves with solving linear equations with only one variable. Thank you for watching this video on Introduction to Linear Equations. In the next video, we are going to see how to solve linear equations. Bye-bye. We are on the topic linear equations and linear inequalities. We are beginning with linear equations. In the previous video, we learned about the introduction to linear equations. We learned what equations are, and we also saw how to identify linear equations and what it means to solve a linear equation. In this video, we are going to take some examples and see how to solve linear equations. To help us understand how to solve linear equations, I have grouped linear equations into types. In this video, we are going to consider the first type. We will consider the other types in the subsequent videos. So let's begin with the first type. The first type is equations with letter on only one side of the equation. The letter here refers to the variable. So in this type of equation, the variable is on only one side of the equation. We are going to see how to solve this type of equation. So when you have such an equation, what do? You group like terms and simplify. You group the terms that are like and you simplify. So what are like terms? For linear equations, you will see that. So what is this? Like terms. That is what I'm going to explain to you. Now, in linear equations, you will see that some of the terms have the variables attached to it. So some terms will have variables attached to it, while other terms will have no variable attached to it. So what we mean by group like terms is that group all the terms with the variables attached to it on one side of the equation, then group all the terms with no variable attached to it on the other side of the equal to sign. So let's say you group all the terms with variables attached to it on the left side of the equation. Then you group all the terms without variable attached to it on the right side of the equation. Now, after you've been able to do that, the next thing is that you simplify what you have. Now, in grouping like terms, remember that the sign of a number changes when it crosses the equal sign. That means that positive becomes negative and negative becomes positive. When we pick examples, you understand what this statement here means. So let's solve some examples. Solve for x in the following. You have been given 4 questions, so we take them one after the other. We take the first one. We have 3x is equal to 15. Now, this is the simplest form of the linear equation that you can get. So we are going to begin from the simplest form, then we gradually increase the difficulty level. It's not going to be so difficult. We are just going to upgrade what we do from here. So we have the first type, which is 3x is equal to 15. Now, the point told us that whenever we have this, the first thing we need to do is to group like terms. From there, we simplify. So here, let's see if we can group like terms. We have 3x is equal to 15. The terms has already been grouped for us. The term with x attached to it is on the left hand side. The terms without x attached to it is on the right hand side, and we have only 2 terms. We have 3x and 15. So like terms has already been grouped for us. So here we assume that we have grouped like term because it has already been grouped for us. Now, because we have been able to group the like terms, or the like term has been grouped for us, the next thing we need to do is to simplify. So here we are going to simplify. We are going to make x stand alone. Remember when we said that if you are being told to solve a linear equation, what it means is that find the value of the variable in the equation. So here we are finding the value of x. What that means is that we are making x the subject. We are making x stand alone. So we have to find a way to make x stand alone. Now let's look at something. 3 is attached to x. What this means is that 3x here will give us 3 times x. We learned from algebra that when we see 2 numbers attached like this, it means they are multiplying. So 3x here means 3 times x. 3 is multiplying x, and we want x to stand alone. So we have to find a way to get rid of 3. Now, how do we get rid of 3? To help us get rid of 3, we are going to divide what we have here, 3x here, by 3. That is the number attached to the 3. Because if we divide it by 3, from division of fractions, you've seen that when you are dividing fractions, common factors on the numerator can cancel common factors on the denominator. So as soon as we divide this by 3, you will see that the 3 that is on the denominator here can cancel itself. The 3 will cancel itself and cancel the 3 on the numerator. You see that we have now gotten rid of the 3 that was attached to the x. That is our main aim. So we have been able to cancel the 3 that is attached to the x. We've been able to cancel it out. That is what we want, and that is what we wanted, and we have been able to achieve it. Now, because this is an equation, what you do to the left hand side, you do the same thing to the right hand side. So if you are dividing 3x here by 3, you can't leave this side. You have to divide here also by 3. So we are going to have 15 divided by 3. Now, as you can see, 3 will cancel itself here and cancel this 3 here. So it means that we've gotten rid of this 3 here. So the numerator part here is x, because this 3 is gone. Now here, 3 cancels itself 1. So the denominator here is going to be 1. When you come here, 15 divided by 3, 3 will cancel itself 1 and cancel 15 5 times. We know that any number divided by 1 is the same number. So x divided by 1 will give us x. 5 divided by 1 will give us 5. So you've seen how this is done. To help us get x, we divide x by the number attached to x so that that number can cancel itself out. So when you do that, x will stand alone. And what you do to the left hand side, you do the same thing to the right hand side. So you divide 15 also by the number attached to x, which is 3. And we did the simplification, and we're having x is equal to 5. Let's take the next type of question. We have 4x plus 2 is equal to 10. Once again, when you have this, what the point told us was that we have to group like terms and simplify. So what are like terms here? Now we can see that 4 here has s attached to it, but 2 does not have s attached to it. 10 also does not have s attached to it. What it means is that 2 and 10 are like terms, so you group them. Now because 4x here is the only 4 here is the only term with s attached to it, it will be on one side. Then 2 and 10 will also be on the other side. 4x is already on the left hand side, so I will leave it there. So I'm going to leave 4x here. Then I will take 2 from this side and bring it to this side. So you see that 2 will cross the equal to sign. Now because 2 is crossing the equal to sign, remember the point told us in the beginning that when a number crosses the equal to sign, the sign on it changes. If it's positive, it becomes negative. If it's negative, it becomes positive. So what is the sign for 2 here? The sign of a number is the sign in front of it. So the sign in front of 2 is positive, which means that 2 here is positive. When it crosses the equal to sign, it becomes negative. 10 is already here, so I will keep 10. 2 is positive. When it crosses, it becomes negative, so it becomes minus 2. Now this is going to give us 4x is equal to 10 minus 2 is 8. Now you see, this is the same as the first example that we had. What do? We divide 4x here by 4 so that we can get rid of 4. Then we divide 8 also by 4, because what you do to the left hand side, you do the same thing to the right hand side. Now 4 will cancel 4, so we are going to have x. 8 divided by 4 will give us 2. Let's consider the next example. We have 2x minus 3 is equal to 7. So once again, you group like terms. We know from here that 3 and 7 are like terms, so you group them together. Now 2x here is the only term with s attached to it, so it will be on one side. Because it's already on the left hand side, I will not worry myself with sending it here, so I'm going to keep it here. Rather, I will send the 3 to this side. The sign in front of 3 is minus, so it means that this 3 here is negative. So when it crosses the equal to sign, it becomes positive. So I'll keep 2x here. 7 is already the first term here, so that's also there. Now 3 here is negative. When it comes here, it's going to be positive. So 7 plus 3. So 2x will give us 7 plus 3, which is 10. Once again, what do you do here? You divide here by 2, divide here by 2, so that we can get rid of 2 here. So 2 will cancel 2 to give us x. 10 divided by 2 will give us 5. Let's consider the next example. 13 minus 5x is equal to 3. Once again, you group like terms. That is the first thing you need to do in this type. You group like terms. So how do you group like terms? You first have to identify the like terms. We have 5x here. It is the only term with x attached to it in this whole equation. So it will stand alone. Now 13 and 3 are like terms. So I'm going to group 13 and 3 at one side. Now because I already have this here, I'm not going to send it to this side. I already have minus 5x here. I'm not going to send it to the other side. I will keep it here. The sign in front of 5 is minus, so it means that this minus here belongs to 5x, so the minus will be here. The sign in front of 13 is positive. When you write a number with no sign in front of it, it means that it's positive. Now because there's no sign in front of 13 here, it means that 13 is positive. So when 13, which is positive, crosses the equal to sign to this side, it's going to be negative. So I'm going to have minus 5x, I'll keep it at this side. 3 is the first term here, so I'll write it. Then 13 will come to this side to be minus 13, because 13 was positive, so when it comes here it becomes minus 13. So I'm going to have minus 5x is equal to 3 minus 13 will give us minus 10. So what do? The number attached to s is minus 5. I want s to stand alone. I want to free x. I want to make s the subject. So what do? I will divide s by the number attached to s. The number attached to s is minus 5. So I will divide minus 5s by minus 5, so that the minus 5 and the minus 5 will cancel for s to stand alone. Now what I will do to the left hand side, I will do the same thing to the right hand side. So I have to divide minus 10 here also by minus 5. Here when you cancel, we are going to have s here. Minus 10 divided by minus 5 will give us positive 2. So s is equal to positive 2. Thank you for watching this video on linear equations. Pick more examples on this type of linear equations and try your hands on them. In the next video, we are going to see how to solve the second type of linear equations, where you have the variable or the letter on both sides of the equation. Bye-bye. We are on the topic linear equations and linear inequalities, but we are concentrating on linear equations now. In the previous video, we learned how to solve the first type of linear equations, where you have the variable on only one side of the equation. In this video, we are going to learn how to solve the second type of linear equations, where you have the variable on both sides of the equation. So let's begin and learn how to do that. Now type 2, letter or variable on both sides of the equation. What do? You group like terms and you simplify, just as we did for the previous one. In this type 2, the first thing you need to do is to group like terms. After that, you simplify. Let's pick some examples and see how to apply this point. Solve for x in the following. So we have 3x plus 1 is equal to 2x plus 5. We have 5x minus 3 is equal to 3x plus 7. We have 7x plus 3 is equal to 3x minus 5. And we have 24 minus x is equal to minus 3x minus 2. You take them one after the other and see how this is done. So we pick the first one. 3x plus 1 is equal to 2x plus 5. Now, the point says that we should group like terms. That is the first thing we need to do. We group like terms. So we first have to identify the like terms. As I said, here, like terms are terms with x attached to it and terms without x attached to it. So all terms with s attached to it are like terms. All terms without s attached to it are also like terms. So when you come here, 3 here has s attached to it, so we have 3x. 2 here has s attached to it, we have 2s, which means that 3x and 2x are like terms, so they will be on one side. Now 1 does not have s attached to it, 5 does not have s attached to it, so 1 and 5 will also be on one side. I hope that is clear. So you group all terms with s attached to it on one side, all terms without s attached to it on the other side. So let's do that. I already have 3x here, so I'm going to keep it. Then I'll bring 2x from this side to this place. Now when I bring it here, you see that here will be left with only 5, so I'll keep 5 here. Then I'll take 1 from this side and send it to this side. So I'll group the terms with s attached to it on the left hand side, and I'll group terms without s attached to it on the right hand side. Okay, 3x here, I'll keep it, so I'll first have 3x. Now 2x here is positive, there's no sign in front of it, which means that it's positive. Now if it's positive, when it crosses the equal to sign to this side, it becomes negative. So I'm going to have 3x minus 2x. Now 5 is already here, so I'll keep it because the sign in front of it is positive and it's the first term. We don't write plus 5x, we just write 5. It means that it's positive, so I'll have that 5 there. Now 1 here is positive, the sign in front of it is plus, so when you bring it to this side, it becomes negative. Now it will come and meet 5. 5 is already there, so I have 5 here, so I'm going to have 5. Then 1 here, when it comes here, it becomes minus 1, so the sign will change to negative, so minus 1. We've learned from algebra that 3x minus 2x is x, because when you have two like terms here subtracting, you subtract the coefficients, so it's going to be 3 minus 2, then you attach the variable to it. So 3 minus 2 is 1. When you attach the variable to it, it's going to be 1x. You know that 1x is the same as x, so 3x minus 2 will give us x. 5 minus 1 will give us 4, so it means that x is equal to 4. Let's move on to the next example. You have 5x minus 3 is equal to 3x plus 7. So once again, you group like terms. So what are the like terms? 5x and 3x are like terms, minus 3 and 7 are like terms, so you group them. As I said, I usually prefer sending the terms with variable attached to it on the left hand side, then sending the other terms on the right hand side. That's what I prefer, but you can choose to do it the other way around. You can choose to send 5x to this side and bring 7 here. Any other way it will work, but I prefer keeping the terms with x attached to it on the left hand side here, then sending the other terms on the right hand side. So I'm going to keep 5x here, then I'll bring 3x from this side. 3x is positive, so when I bring it to this side, it's going to be negative. 7 here is positive, so it will be there. 3 here is negative, so when I send it to this side, it's going to be positive, which means I'm going to have 5x. 3 when it comes here becomes negative, so minus 3x. Then I have the equal to sign. I keep 7. Now here 3 is minus, so when it crosses the equal to sign to this side, it becomes positive, so 7 plus 3. We know from indices that 5x minus 3x will give us 2x, because you are going to subtract the coefficient. So 5 minus 3, that will give us 2. Then you attach the variable to it, so 5 minus 3, which is 2. The variable there is x, so 2x. If you want to understand how this is done, watch the video on addition and subtraction of algebraic expressions, and you understand how this part here is done. 7 plus 3 will give us 10. So this looks like the first type that we saw. We say when you get here, what do? You divide both sides by the number attached to x. The number attached to x is 2, so we divide here by 2, we divide here by 2, and x is going to give us 5. Let's move on to the next example. We have 7x plus 3 is equal to 3x minus 5. Once again, you first identify the like terms, then you group them. 7x and 3x are like terms. 3 and minus 5 are like terms, so you group them. So as I said, I will keep 7x here, then I'll bring 3 to this side. So I keep 7x. 3 here is positive, so when it crosses the equal to sign to this side here, it becomes negative. Once again, remember that the negative here is for the 5, not 3. The sign for 3 is in front of it here. Because there is no sign here, it means that it is positive. So 3x here is positive. The negative here belongs to the 5. It does not belong to 3. So 3 here is positive. When it crosses the equal to sign to this side, it becomes negative. So I'm going to have 7x minus 3x is equal to, now I have minus 5 here, so I'll keep minus 5 here. 3 here is positive. When it crosses the equal to sign to this side, it becomes negative. So minus 3. 7x minus 3x from algebra, we know that that will give us 4x. Minus 5 minus 8 will give us, minus 5 minus 3 will give us minus 8. Once again, what do? We divide both sides by the number attached to the variable when you get to this stage. So we divide both sides by 4, which is the number attached to the variable. So we divide here by 4. We divide here by 4. 4 will cancel 4 to give us x. Minus 8 divided by 4 will give us 2. Let's consider the last example. We have 24 minus x is equal to minus 3x minus 20. So once again, you identify the like terms, you group the like terms, then you simplify. So here, the like terms are minus x and minus 3x. They are the like terms, so you group them. 24 and minus 20 are also like terms, so you group those ones too. So as I said, I prefer keeping the terms with x on it on the left hand side. So I'm going to keep minus x here. Then you can see from here that the sign in front of this 3x here is minus, which means that 3x here is minus. So when I bring it to this side, it's going to be positive. Here, the negative here is for the 20. So I'm going to have negative 20 here. 24 here is positive because there is no sign in front of it here. So because it's positive, when it crosses the equal to sign to this side, it becomes negative. So I'll keep minus x here, then plus, when I bring this one to this side, it becomes 3x. Because it's negative, when it crosses, it becomes positive. So plus 3x is equal to, I have minus 20 here. 24 here is positive. When it comes here, it becomes negative. So minus 24. Now, from indices, we know that minus x plus 3x will give us 2x. The reason being that the coefficient of this minus x here is 1. Now, because the coefficient of this minus x here is 1, sorry, I'm using the pen on my laptop, that's why I'm not able to write it well. I'm going to write 1 well so that you see what I'm talking about. So the coefficient of this minus x here is 1. So we have minus 1x or minus x1 will give us 3x. So what you do is that you add the coefficient. So I'm going to have minus x minus 1 plus 3, and that will give us positive 2. Okay, so I'm going to delete this one so that I write it well. I should have written it in front. Sorry. Okay, so this is what I mean. Now minus x is the same as minus 1x. Now if you have this, what you do is that it's going to be minus 1 plus 3. That will give us 2. Then we attach the variable to it, which is x, so that will give us 2x. That is why minus x plus 3x is giving us 2x. Once again, if you are not so clear with this, watch the video on addition and subtraction of algebraic expressions and you see how this is done. So here we have minus 20 minus 24, that will give us minus 44. You divide both sides by 2 and s will give us minus 22. Thank you for watching this video on linear equations. Pick more examples on this type of linear equations and try your hands on them. If you have any problems, interact with me on my social media handles and I'll help you to solve them or to understand it very well. In the next video, we are going to consider the third type of linear equations, where the linear equation will involve a fraction. Where the linear equation will involve a bracket. Bye bye. We are on the topic linear equations and linear inequalities, but we are concentrating on linear equations in this video. In the previous video, we learned how to solve the second type of linear equation, where we have the letter or the variable on both sides of the equation. In this video, we are going to learn how to solve the third type of linear equation, where we have brackets in the equation. Now, when you have brackets, what do? Type 3, equations involving brackets. The first thing you need to do is to first expand the brackets. So whenever you have brackets, the first thing you need to do is to expand the bracket. After you expanded the bracket, you group like terms and simplify. So the first thing you need to do is to expand the bracket. You see that after you've expanded the bracket, you are going to get type 2. What do you do in type 2? You group like terms and you simplify. Let's pick some examples and see how this is done. The question says that we should find the truth set of the following. Here it means that we should solve the following, just that we are going to present our answer in a different form. So whenever you see find the truth set of something, it means find the truth set of an equation. It means solve the equation. You are going to present your answer in a different way, and I'll show you how to present your answer. So our task is to solve the equation. So we pick the first one. We have 5 into brackets x plus 4 is equal to 35. So as the point told us, the first thing we need to do is to expand the brackets. You see here it says brackets. If you have more than one bracket, but here we only have one bracket, so we are going to expand the brackets. Now, how do we expand the bracket? We learned from expansion of algebraic expressions that whenever you have a term outside a bracket like this, the term outside the bracket will multiply every term in the bracket. So here 5 is outside the bracket, so it will multiply every term in the bracket. What that means is that 5 will multiply x, and at the same time 5 will multiply 4. Once again, if you watch the video on expansion of algebraic expressions, you will see how this is done. So we are going to expand. So 5 will multiply x to give us 5x. Then 5 will multiply 4 to give us 20. We have this is equal to 35. Now you see that this becomes like type 1. So what do we do from here? We group like terms. In grouping like terms, you know that 20 and 35 are like terms, so we group them. So I'll keep 5x here. We have 35. 20 here is positive. When it crosses the equal to sign to this side, it becomes negative. So I'm going to have 5x is equal to 35 minus 20. 35 minus 20 is 15. So 5x is equal to 15. We divide both sides by 5 to make s the subject, or to find s, and s will give us 3. Now the question told us to find the truth set. To find the truth set, it means that you have to give your answer in the form of a set. We know that in sets we write our answer in a curly bracket. So what you do is that we say therefore the truth set is, you write a curly bracket, then you write the variable. We say that s is such that s is equal to 3. So this is the truth set. You see, we learn from sets that the members of a set are written in a curly bracket. So you write the curly bracket, then you say that the variable, which is x, is such that x, which is the variable again, is equal to 3. So this is the truth set of the equation that we have here. Let's pick another example. We have 5x minus 3 is equal to 3 into bracket x plus 4. So once again, you expand the bracket. So when you have brackets, the first thing you need to do is to expand the bracket. We do not have any bracket here, so we are going to write that 5x minus 3. We have brackets here, so we expand it. So 3 times x give us 3x. 3 times 4 will give us 12. I hope that is clear. Now after you've done this, you see that this is like type 2. We have variables on both sides of the equation, so we group like terms. So first identify the like terms. The like terms are 5x and 3x, then 3 and 12. So you group them. As I told you in the previous video, I prefer grouping the terms with s on it on the left hand side, then grouping the other terms on the right hand side. So I'll bring 3x to this side. So 5x is already here, I will keep it. So I have 5x here. 3x here is positive, so when it crosses to this side, it becomes negative. So 5x minus 3x will give us 12 here is positive. When 3 here is negative, when it crosses to this side, it becomes positive. So 12 plus 3. So at this moment, you should be conversant with how the numbers changes sign when they crosses the equal to sign. Remember that whenever if you don't change the sign when the number crosses the equal to sign, you are going to have a wrong answer. So take care when the numbers are crossing. So 3x here is positive, when it crosses it becomes negative. 3 is negative, when it crosses it becomes positive. So let's move on. 5x minus 3x will give us 2x. We know this from indices. 12 plus 3, we can do this. We know that 12 plus 3 is 15. When you have this, what do? You divide both sides of the equation by 2. So when you do that, 2 is going to give us 15 over 2. If you watch the video on conversion of improper fractions to mixed numbers or mixed fractions, you will see that 15 divided by 2 give us 7 whole number 1 over 2, because 15 will divide 2 will divide 15 7 times, then we have 1 over 2 as the remainder. So x will give us 7 whole number 1 over 2. But the question told us to find the truth set of the equation. So we say that the truth set is given as, you draw your curly bracket, x, which is the variable, is such that, so you bring this sign, x is equal to 7 whole number 1 over 2. So this is the truth set of the equation. Let's make the next example. We have 5 into bracket x minus 4 is equal to minus 2 into bracket 3 minus x. So here we have brackets on both sides of the equation, so you expand them. So we are going to have 5 times x, which is 5x, 5 times minus 4, which is minus 20, is equal to minus 2 times 3, which will give us minus 6. Now minus 2 times minus x, which will give us positive 2x, because we know that when negative multiplies negative, you are going to get positive. Once again, if you watch the video on multiplication of algebraic expressions, you will see that in that video we said when a negative term multiplies another negative term, the result will be a positive term. So minus 2x times minus x will give us 2x. So here we have type 2. So what do? We group like terms. 5x and 2x are like terms, so we group them on one side. Negative 20 and negative 6 are also like terms, so we group them on the other side. So once again, I'll keep my 5x here. Then I'll take 2 from this side and bring it here. It's crossing the equal to sign, so it becomes minus 2x. I'll keep negative 6 here. 20 is positive, when it crosses it becomes negative. 20 is negative, when it crosses it becomes positive, so plus 20. 5x minus 2x from algebra, we know that that is 3x. Minus 6 plus 20 will give us 14. Now we divide both sides by 3, so we divide here by 3, we divide here by 3, and we are going to have 3 will cancel itself here. 3 will divide 4, 3 will divide 14 4 times, then the remainder 2 over 3. If you want to see how this conversion is done, watch the video on conversion of improper fractions to mixed numbers or mixed fractions, and you understand how this conversion was done. So x is going to give us 4 whole number 2 over 3. The truth set is s is such that x is equal to 4 whole number 2 over 3. Let's consider the next example. We have 4 into bracket 3 minus 5y is equal to minus 7 into bracket 5 minus 4y. So once again, you open the brackets. So you use the term outside to multiply the term inside. So 4 times 3 will give us 12. 4 times minus 5y will give us minus 20y. We have our equal to sign. minus 7 times 5 will give us minus 35. Minus 7 times minus 4y will give us positive 28y. So here we identify the like terms and we group them. The like terms are minus 20y and 28y. They are like terms. 12 and minus 35 are also like terms. So I'll group them. I will keep minus 20y here. Then I'll bring 28y from this side to here. 28y is positive. When it crosses to this side, it becomes negative. So I'm going to have minus 20y minus 28y. I already have minus 35 here, so I'll keep minus 35. 12 here is positive. When it crosses to this side, it becomes negative. So I'm going to have minus 20y minus 28y is equal to minus 35 minus 12. Minus 20y minus 28y will give us minus 48y, because minus 20 minus 28 will give us minus 48. You attach the variable which is y to it. Minus 35 minus 12 will give us minus 47. So here we divide both sides by minus 28. That is the number attached to the variable. So we divide both sides by minus 28. And y will give us 47 divided by, sorry, here we divide both sides by minus 48, not 28. So here minus 48 minus 48. So y will give us 47 over 48. Because the negative here will cancel the negative here. So y will give us 47 over 48. The question told us to find the truth set. So we see that the truth set is, you draw your curly bracket, then the variable here is y. Remember, we were using x in the previous example because the variable there was x. But here, because the variable is y, you see that y is such that y is equal to 47 over 48. So this is the truth set of the equation above here. Thank you for watching this video. Pick more examples on this type of linear equations and try your hands on them. If you have any problems solving them, you can interact with me on my social media handles and I'll help you to do that. In the next video, we are going to consider the next type of linear equation where the equation will involve a fraction. Bye bye. We are on the topic linear equations and linear inequalities, but we are concentrating on linear equations for now. In the previous video, we learned how to solve linear equations that involve brackets. In this video, we are going to learn how to solve linear equations that involve fractions. So how do you solve linear equations that involve fractions? Type 4, linear equations involving fractions. When you have linear equations that involve fractions, the first thing you need to do is to clear the fractions by multiplying each term by the LCM of the denominators. So what you do is that you first have to identify the fractions in the equation. Now after you've identified the fractions, you must find the LCM of the denominators. You've learned how to find LCM of numbers. So you must find LCM of the denominators. Now after you find the LCM of the denominators, you multiply each term. Take note of this. You multiply each term in the equation by the LCM, and that will clear the fraction. So you multiply each term in the equation by the LCM of the denominators. Now after you've done that, you cancel out the common factors. When you cancel out the common factors, you clear all the fractions. After that, what do? Expand the brackets if there are any. Sometimes the question already have a bracket. Sometimes too, you have to introduce the bracket as a result of some multiplication that you do. You will learn what all this means in the examples that you take. So whatever it is, when you have brackets, after you've cancelled out the common factors, you expand the brackets. After you've expanded the brackets, you group like terms and you simplify. Let's pick some examples and see how we can apply the steps that we've learned in this slide. So solve for x in the following. We have been given 5 questions, so you take them one after the other. The first one is 1 over 5 into bracket 3x plus 4 is equal to 2. So the first step you need to do is to first identify the fractions in the equation. In this equation, we have only one fraction, which is 1 over 5. So in this equation, the only fraction we have is 1 over 5. Now the denominator of the fraction is 5. So here, because we have only one fraction, we are going to find LCM of 5, the least common multiple of 5, which will be 5 because we have only one fraction. So the LCM will be the denominator of that fraction that we have. I hope that is clear. Because here the only fraction in this equation is 5, the LCM is going to be 5. So we have the LCM to be 5. Now after you found the LCM to be 5, the next thing you need to do is to identify the terms in the equation. The terms in the equation. So when you come here, you see that everything here is together. Everything here is together. So it means that this whole thing here is one term. This one here is also another term. So we have two terms in this equation. Because everything here is together, it's not separated by a minus sign or a positive sign. 1 over 5 and what is in the bracket here is multiplying. So this whole thing here is one term. 2 here is also another term. So what you do is that you multiply each term by the LCM that we found. The LCM we found was 5. So you multiply what is the whole thing here by 5 and you multiply 2 by also 5. So 5 times everything here, which is one term. So 1 over 5 into bracket 3s plus 4, then is equal to 5 times the term we have here, so 2 times 5. Now after you finish with this, the point is that we should cancel out common factors. We can see clearly from here that 5 will cancel itself 1 and cancel 5 1. So you see we've cancelled out this. Now after you've done the cancellation, you see that you clear the fractions away. Now after this cancellation, you can see we are going to have, so here is 1, this one will give us 1 over 1, which is also 1. So you are going to have 1 times 1 over 1 here is 1, then what we have in the bracket 3x plus 4, 2 times 5 will give us 10. Now 1 times 1 will give us 1. 1 times what is in the bracket will give us the same thing in the bracket, which is 3x plus 4. So I hope that is clear. So 1 times 1 here is 1. That 1 times what is in the bracket is the same thing. Any number times 1 is the same number. So 3s plus 4 times 4, all of them times 1 will give us 3s plus 4. So we are going to have 3s plus 4 is equal to 10. From here, we can group like terms. We've done a lot of this. So we are going to have 3s is equal to 10 minus 4. Since 4 is positive here, when it crosses, it becomes negative. So 3x will give us 6. We divide both sides by 3 and x will give us 2. So once again, you look for the fractions. You look for the LCM of the denominators of the fractions. You multiply each term by the LCM. You cancel out. You expand the brackets. Then you group like terms and simplify. Let's take another example. So here, let's look for the fractions. We have two fractions here. We have 3x over 2, 5x over 3. So these are the two fractions that we have. So look for the denominators of the fractions. So here the denominators of the fractions are 2 and 3. Now look for the LCM of the denominators. So it means that we are looking for the LCM of 2 and 3. We know that the LCM of 2 and 3 is 6. So the LCM that we found is 6. Now after you found the LCM to be 6, the next thing you need to do is to identify the terms in the equation. The terms in the equation. Now we can see from here that 3x over 2 here is on its own. Then we have minus here, then 5x over 2. So 3x over 2 is being separated from 5x over 3 here by the negative sign. So it means that 3x over 2 here is one term, 5x over 3 here is another term, then 1 is also another term. I hope that is clear. So 3x over 2 is one term, 5x over 3 is one term, and 1 is also another term. Now what do we do with the LCM that we found? Multiply each term by the LCM. So we are going to have 6 times 3x over 2. So we've multiplied this term by the LCM, which is 6. Now when you come here, you multiply this term also by the LCM. So minus, we bring the LCM, which is 6, times this term, which is 5x over 3. When you come here, you multiply this term also by the LCM. So 1 times 6 here. I hope that is clear. Now let's move on. We cancel out. After you multiply each term by the LCM, you cancel out. So it means that 2 will cancel itself 1 and cancel 6. We know that that will be 3. 3 will cancel itself 1 and cancel 6 2 times. 2 times. Then 1 times 6. Because they are multiplying, you can't cancel anything out. So we are going to have 3 times 3x, then minus 3 cancel itself 1, cancel 6 2 times. We have 2 times the numerator here, which is 5x, is equal to 1 times 6. So you see, we have been able to clear the fractions. So here we do the multiplication. 3 times 3x will give us 9x, minus 2 times 5x will give us minus 10x. 1 times 6 is 6, so we have 6 here. Now you can see from here that we don't have brackets, so we will not concern ourselves with the brackets first. We don't have brackets, so we straight away move on and simplify. Once again, the like terms has also been grouped for us, so all that we need to do is to just simplify. 9x minus 10x will give us minus x, and this will give us 6. Remember, the question told us to find x, solve for x, not solve for minus x. So in order to find x, we divide both sides by minus 1, because the number attached to x here is 1. So we divide both sides by minus 1, and x is going to give us, so here the negative will cancel negative. X divided by 1 is 1. 6 divided by minus 1 is minus 6. Hope that is clear. We move on to the next example. We have 2x minus 1 over 3 minus x minus 2 over 4 is equal to 1. So the first thing we need to do is to identify the fractions. The fractions are 2x minus 1 over 3 and 4x minus 2 over 4. So after you identify the fraction, look for the denominators of the fractions. The denominators are 3 and 4. Then find the LCM of the denominators. So you find LCM of 3 and 4. And when you do that, you know that the LCM is 12. Now I'm going to show you a trick. If you are finding it difficult finding the LCM, don't worry. Just multiply the denominators. So multiply 3 by 4 and use it at the LCM. So if you multiply 3 by 4, you are going to get 12. Okay. So after you find the LCM, you multiply each term in the equation by the LCM. So when you come here, 2x minus 1 over 3 is one term. We have the negative sign here, so x minus 2 over 4 is also another term. Then 1 is also another term. So terms in an equation are separated by a negative or positive sign. So this whole thing here is being separated by a negative sign, which means that this one here is one term. Then the minus sign will come. This whole thing here is also another term. Then this one is also another term. So you multiply each term by the LCM. What is the LCM? 12. So you are going to multiply 2x minus 1 over 3 by 12. You multiply x minus 2 over 4 by 12. And you multiply 1 by 12. We cancel out. 3 will cancel itself out 1 and cancel 12 here 4 times. 4 will cancel itself 1 and cancel 12 3 times. So you are going to have 4 times. Now because what we have on the numerator here is a binomial, we have two terms. We learned in algebraic expression that whenever you have a single term multiplying two terms, you have to put the two terms in a bracket. So because what we have here are two terms, 2x and minus 1, we will put them in a bracket. Then we will bring the single term, which is 4, outside the bracket. So we have 4 into bracket 2x minus 1. When you come here, 4 will cancel itself 1 and cancel 12 3 times. So we are going to have 3 times x minus 2. But because we have what we have here, which is x minus 2, is a binomial, you are going to put that in a bracket. Binomial is an expression with two terms. So because we have x and minus 2, this is a binomial, you put that in a bracket. When you come here, you have 1 times 12, which is 12. So we have a bracket here. So you can see from here that the question did not have a bracket, but we had to introduce the bracket so that we'll be able to solve the question. Okay, so we have the bracket here, so we expand the bracket. 4 times 2x will give us 8x. 4 times minus 1 will give us minus 4. 3 times x minus 3 times x will give us minus 3x. Minus 3 times minus 2 will give us positive 6 is equal to 12. So here we group like terms. 8x and minus 3x are like terms. Minus 4, 6 and 12 are also like terms. Now we group them. So I'm going to have 8x then minus 3x. They are all already here, so I'm not going to transfer them. So I'll rather transfer the numbers to this side. I have 12 here, so if I transfer minus 4 from this side to this side, it becomes positive 4. If I transfer positive 6 from this side to this side, it becomes negative 6. 8x minus 3x will give us 5x. 12 plus 4 will give us 16. 16 minus 6 will give us 10. We divide both sides by 5 and x will give us 2. Let's move on. We have 1 over 4 into bracket x plus 1 minus 1 over 2 into bracket x plus 2 plus x is equal to 3 whole number 1 over 4. Now, whenever you have a question like this with a mixed number or mixed fraction in it, the first thing you need to do is to convert the mixed fraction or mixed number into an improper fraction. So that's the first thing we need to do. So we have 1 over 4 to bracket x plus 1 minus 1 over 2 into bracket 2 plus x is equal to, you convert 3 whole number 1 over 4 to an improper fraction, and that will give us 13 over 4, because 4 times 3 is 12. 12 plus 1 is 13. So 13 divided by 4. If you want to understand how this is done, watch the video on converting converting mixed numbers or mixed fractions to improper fraction under fractions, and you understand this very well. So we now have all of them here in fractions form. So what you do is that you look for the fractions. The fractions are 1 over 4, 1 over 2 and 13 over 4. Then you look at the denominators, which are 4, 2 and 4. You look for the LCM of the denominators. So the LCM of 4, 2 and 4 is 4. So that is the LCM that you are going to use. The LCM you are going to use here is 4. Once again, if you are finding it difficult finding the LCM, multiply the denominators. 4 times 2 times 4. Then the value that you get, use that value as the LCM. After you simplify, you are going to get the same answer. It is always easier to find the LCM, but if you are finding it difficult, just multiply the denominators and use it as the LCM. So here I'm going to use the LCM, which is 4. Multiply each term by the LCM. Now here, what are the terms here? This whole thing here is one term. 1 over 4 into bracket s plus 1 here is one term. When you come here, you see we have a negative sign here, so it means that 1 over 2 into bracket 2 plus x is also another term. So terms in the equation are separated by the negative sign or positive sign. So everything here is together one term, everything here is also together one term, then 13 over 4 is also together, so that's also another term. So what you do is that you multiply each term by the LCM. So you multiply this term here by 4, you multiply this term here by 4, you multiply this term here by 4, then you cancel out. So 4 will cancel 4, 2 will cancel itself 1 and cancel 4 2 times, 4 will cancel 4. So we are going to have, when 4 cancels 4, we are going to get 1. 1 times 1 will give us 1, so 1 into bracket s plus 1. 2 will cancel itself 1, then we are going to have 2 cancel 4 2 times, so here is going to be 2, so we are going to have minus 2 times the numerator here, which is 1, and that will give us minus 2. Remember, here is already 1, so any number divided by 1 is the same number, so minus 2. Then we bring our bracket 2 plus x is equal to 13. So you see in this question, the question had the bracket. In the previous example, we had to introduce the bracket. So here, because we have a bracket here, you expand the bracket. 1 times any number is the same number, so 1 times s plus 1 will give us s plus 1. When you come here, minus 2 times 2 will give us minus 4. Minus 2 times x will give us minus 2x. Then we have this is equal to 13. We group like terms. So x and minus 2x are like terms. Because they are already on the left hand side here, I'm going to keep them there. So I have s minus 2x is equal to, I have this first term here which is 13, so I will transfer all the numbers to this side. So positive 1, when it comes here it becomes negative 1. Negative 4, when it comes here it becomes positive 4. Now x minus 2x, we've seen that this will give us minus x. From algebra we know that s is the same as 1s, so x here is the same as 1s. So if you have 1x minus 2x, we are going to have minus 1 because 1 minus x, because 1 minus 2 give us minus 1. So we are going to have minus x. Then 13 minus 1 will give us 12. 12 plus 4 will give us 16. So minus x is equal to 16. The question told us to find x, not minus x. So you divide both sides by x. And when you do that, you divide both sides by minus 1, and when you do that, x will give us minus 16. Let's consider the last example here. We have 1 over 3 into bracket 2x minus 1 minus 4 over 9 into bracket 3x minus 2 into bracket minus 1 over 9. So once again, you look at the fractions. The fractions are 1 over 4, 1 over 3, 4 over 9, 1 over 9. Then you look at the denominators. The denominators are 3, 9, and 9. You look for the LCM of the denominators. The LCM of 3, 9, and 9 is 9. So you multiply each term by the LCM. So you multiply each term by 9. You know that this is one term, this is one term, then this is also one term. So you multiply the first term by 9, the second term by 9, and the last term also by 9. We cancel out. 3 will cancel itself 1 and cancel 9 3 times. So you are going to have 3 times 1, which is 3. Then we bring the brackets. So bracket 2x minus 1. 9 will cancel itself 1 and cancel 9 1 time. So we are going to have 1 times 4. Remember, we already have negative here, so that's going to give us negative 4 into brackets. We bring the bracket. We bring what is in the bracket, which is 3x minus 2. 9 will cancel itself 1 and cancel 9 1. So we are going to have minus 1 times 1, which will give us minus 1. From here, we expand the brackets. So we are going to have 3 times 2x, which will give us 6x. 3 times minus 1 will give us minus 3. Minus 4 times 3x will give us minus 12x. Minus 4 times minus 2 will give us positive 8 is equal to negative 1. We group like terms. So we are going to have 6x minus 12x is equal to, I'll transfer all the numbers to this side. So I already have minus 1 here. So when I take negative 3 to this side, it becomes positive 3. If I take positive 8 from here to this side, it becomes negative 8. 6x minus 12x will give us minus 6x. Minus 1 plus 3 will give us 2. 2 minus 8 is minus 6. We divide both sides by minus 6 and x is giving us 1. Thank you for watching this video on linear equations. We've considered all the 4 types of linear equations, so you should be able to solve any linear equation at this point. To help you, pick more examples and try your hands on it. In this video, we considered just 4 examples. There are a lot of examples that you can try your hands on it, so pick more examples and try your hands on them. If you have any problems, interact with me on my social media handles and I'll help you to do it. In the next video, we are going to learn how to solve practical problems that require the use of linear equations. Bye bye. We are the topic linear equations and linear inequalities. We are dealing with linear equations at the moment. In the previous video, we learned how to solve linear equations involving fractions. In this video, we are going to learn how to solve practical problems that require the use of linear equations. So, practical application. Algebra can be used to solve problems given words or sentences. So, we can use algebra to solve problems when words or sentences are given about the problem. So in this type of questions, we will be given words or sentences about a certain problem. Then we will use algebra to solve it. Now, how are we going to do this? Whenever you are given such a problem, or to solve such a problem, the first thing you need to do is to read the information carefully. This is very, very important. The information that has been given to you, the words or sentences about the problem that have been given to you, you have to read it very carefully. Then, you choose a letter to represent the unknown quantity. Now, you will see that in these types of questions, you will be asked to find something. That is the unknown quantity. Maybe you'll be asked to find somebody's age, somebody's money, a certain number. You'll be asked to find something, number of something. That is what you don't know. That is what we call the unknown quantity. You choose a variable or a letter to represent that unknown quantity. I hope that is clear. So you always have to choose a letter or a variable to represent the unknown quantity. Now, after you've done that, use the information given to form a linear equation in terms of the chosen letter. So the information that you have been given, use that information and the unknown quantity or the chosen letter, the variable that you've chosen, use the information given and the variable to form a linear equation. I hope that is clear. So now if you're going to read the information, you understand what you are being told to do. You choose a letter or a variable to represent the unknown quantity. Then, using the information and the letter that you've chosen, form a linear equation in terms of the letter that you've chosen. Then, you solve the linear equation. So, solve the linear equation you formed. If you solve the linear equation, you'll be able to find the unknown quantity. Let's pick some examples and see how we can apply what you've learned here. We are going to solve 2 examples in this video. Then in the next video, we will solve 2 examples. So let's begin with the first one. If 4 is added to half of a number, the result is 8. What is the number? Now the first point said we should read the information carefully. So let's read the information again. If 4 is added to half of a number, the result is 8. What is the number? So you ask yourself, what does the question want me to find? It is clear in it. The question wants you to find a number, a certain number. So the number that you want to find, that is the unknown quantity. So here, this is a question mark. Okay. Oh, sorry. Okay, so this is a question mark. Find what is the number? The question wants us to find a certain number. We are being told to find a certain number. So we have now seen that number that we want to find is the unknown quantity. The next point was that, so we have been able to read the information carefully. The next point is that we have to choose a letter to represent the unknown quantity. So here the unknown quantity is a certain number that we want to find. So choose a letter to represent that number. So we are going to write the solution here. Now we have to choose a letter to represent the number. So I'm going to say that let the number be equal to x. So now I've chosen x to represent the unknown quantity, which is the number that I want to find. Let's move on. The next point was that we have to use the information and the letter that we've chosen, which is x, to form a linear equation. So that is what we are going to do. Now We have now let the number be s. Let's read the information again. If 4 is added to half of a number, so you are going to consider the first part. 4 is added to half of a number. So 4 is added to half of a number. What this means is that we have now let the number here be equal to s. So from this information, we can say that 4 plus half of the number, which is s. I hope this is clear. So 4 is added to half, which is 1/2 of the number, which is x. We know from our studies in mathematics that whenever you see of, it means multiplication or times. So this is going to give us 4 plus 1/2 times s. Now this s here is the same as s over 1. Any number divided by any number that stands on its own is divided by 1. So this x here is the same as x over 1. So you are going to have 1 times x, then 2 times 1. And this is going to give us 4 plus 1 times x will give us x, 2 times 1 will give us 2. So we are going to have 4 plus s over 2. So we have been able to deal with the first part of the equation, with the first part of the information here. Now let's continue. The information says that if 4 is added to half of the number, the result is 8. So after you've added 4 to half of the number, we are now getting 4 plus s over 2. After you've done this, it says that the result is 8, which means that this whole thing here is 8. That means that 4 plus s over 2 is 8, is equal to 8. I hope that is clear. So let's go through the whole process again. We are going to go through the whole process again so that you get what you want, what you want to do. You read the information carefully. 4 is added. If 4 is added to half of a number, the result is 8. What is the number? You ask yourself, what does the question want me to find? The question wants you to find a number. So you represent the unknown quantity, which is the number, by a variable. We are choosing x. You break the information down. 4 is added to half of a number. So 4 is added to half of a number. We have now let the number be s. So 4 plus half of x. This will give us 4 plus 1/2 times x. And we know this will give us 4 plus x over 2. Now it says that the result is 8, which means that after you've done this, the result is 8. This whole thing here is 8. It's equal to 8. So 4 plus x over 2 is equal to 8. As soon as we form this linear equation, we can now solve the linear equation. So let's solve this. We know that this is an example of linear equations which involve fractions. The fraction here is s over 2. The denominator that we have is 2, which means that we are going to use that as our LCM. So you multiply every term by the denominator. 4 is one term, s over 2 is one term, and 8 is also another term. So you multiply every term by denominator. So 2 times 4 plus 2 times x over 4. 2 times 4 plus 2 times x over 2 is equal to 8 times 2. The denominator is 2. So you multiply every term with 2. So 2 times 4 plus 2 times x over 2 is equal to 2 times 8, or 8 times 2. So 2 times 4 will give us 8. When you come here, 2 will cancel itself 1 and cancel 2, 1. So you're going to have 1 times x, which is x, is equal to 8 times 2, which is 16. So x will give us, you group like terms, we take 8 from this side to this side, it's going to be negative. So s is equal to 16 minus 8, and s will give us 8. So we can see that therefore the number is 8. Now after you find this, try and see if it satisfies the question. The question says that 4 is added to half of a number. We have now found the number to be 8. So half of 8 will give us 4. When you add 4 to 4, what do you get? 8. Remember the question said when 4 is added to half of the number, the result is 8. So you see that when you test it, you see that truly the number is 8. Let's consider the next example. We have 3 is added to 5 times a number and the result is multiplied by 4. The final result is 72. What is the number? So once again, we are going to break this down. So we bring our solution. 3 is added to 5 times a number. The question is telling us to find a certain number. We don't know the number, so I'm going to let the number be equal to 8. So now, we let the number be equal to a. So now we know that the number is a. So we can proceed from here. 3 is added to 5 times the number. What this means is that 3 is added to plus 5 times the number, which we now know to be a. So this is going to give us 3 plus 5 times a will give us 5a. Now let's continue. The result is multiplied by 4. Now when you add 3 to the number, when you add 3 to 5 times the number, we are getting 3 plus 5a. The next point says that the result is multiplied by 4. Which result? This result here is multiplied by 4. Now because what we have here is a binomial, that is 2 terms, and we are going to multiply it by a number here which is 4, you will put the binomial, that is the 2 terms, in a bracket. Then you bring this number outside the bracket. So this is going to give us 4 into bracket 3 plus 5a. So 3 is added to 5 times a number. You know that will give us, if the number is a, that is going to give us 3 plus 5a. The result is 4. So it means that 3 plus 5a is multiplied by 4. The result is multiplied by 4. So 3 plus 5a is being multiplied by 4. Because 3 plus 5a is a binomial, you put that in a bracket, then you bring the 4 outside the bracket. The next part of the statement says that the final result is 72. So after you've multiplied this one by 4, the final result, everything here, is 72, which means that 4 into bracket 3 plus 5a is equal to 72. After you've multiplied this 3 plus 5a by 4, the final result is 72. So everything here is equal to 72. So we now have the linear equation. You expand the bracket, you group like terms, you simplify. So 4 times 3 will give us 12. 4 times 5a will give us 20a, and this will give us 72. So you group the like terms, you are getting 20a is equal to 72 minus 12. 20a is equal to 60. You divide both sides by 20, and a will give us 3. So here the number is 3. So you test and see if this satisfies the equation, if this satisfies the statement. The statement says that 3 is added to 5 times a certain number. So we've now found the number to be 3. So 3 is added to 5 times a certain number. 5 times 3 will give us 15. So 3 is added to 15. That will be 18. So 3 times 3 plus 15 will give us 18. Now it says that the result is multiplied by 4. The result is multiplied by 4, which means that you're multiplying 18 by 4. When you multiply 18 by 4, we know that you are going to get 72 as we have here. So 5 times 3 will give us 15, and 3 plus 15 will give us 18. When you multiply 18 by 4, you are going to get 72 as we have here. So you see that this one also satisfies the equation. So all you need to do is to read the statement carefully. You let a letter or a variable represent the unknown quantity. You form the linear equation, then you solve the linear equation in order to find the unknown quantity. So we can see that the number is 3. Therefore, the number is 3. Remember, the question did not tell you to find a. We just introduced a. So after you finish the whole thing, you have to answer the question. The question said find the number. So the number is 3. Thank you for watching this video on practical problem that involve the use of linear equation. Pick more examples and try your hands on it. If you have any problem with any of the questions, interact with me on my social media handles and I'll help you to solve it. In the next video, we are going to consider 2 more examples on solving practical problems that involve the use of linear equation. Bye-bye. We are on the topic linear equations and linear inequalities. We are concentrating on linear equations for now. In the previous video, we took some examples on solving practical problems that involves the use of linear equations. In this video, we are going to take 2 examples. So let's begin with the first question. Kweku is now 6 times as old as Amma. In 12 years' time, Kweku will be twice as old as Amma. How old are they now? So let's read the question again. Kweku is now 6 times as old as Amma. In 12 years' time, Kweku will be 2 times as old as Amma. How old are they now? What does the question want us to find? The question wants us to find the ages of Kweku and Amma. So these 2 are the unknown quantities. That is what we have to work towards. These 2 are the unknown quantities. Now let's analyze the statement very, very carefully. So we bring our solution here. Kweku is now 6 times as old as Amma. In 12 years' time, Kweku will be 2 times as old as Amma. So the question is talking about 2 times here. It's talking about now. Now let's look at it. The question is talking about now and 12 years' time. Sorry, I'm going to erase this side. I should get it. So the question is talking about now and in 12 years' time. Sorry, I'm not able to underline it very well. I wanted to underline it so that you see it. But I think you get the point. Sorry. Okay, I think this is better. So the question is talking about now and in 12 years' time. You see, your age now and your age in 12 years' time will be different. So here you have been given 2 times, now and 12 years' time. So we are going to deal with now, then we move on to what will happen in 12 years' time. So now, Kweku is now 6 times as old as Amma. So if you are considering now, what this statement means is that, so from here we can see Kweku is now 6 times as old as Amma. What this statement means is that Kweku's age is equal to 6 times Amma's age now. That is the meaning of this statement. Kweku's age now is 6 times Amma's age. I hope that is clear. So if you want Kweku's age now, right now, let's say we are in 2018, if that is the now that is being talked about here, Kweku's age is 6 times Amma's age. So from here we can say that if we let Amma's age is equal to S, or Amma's age to be S, Kweku's age will be 6 times X. So we can say from here that Kweku's age is 6S. So we have let a variable to represent the unknown. So right now we know that if Amma's age is X, because Kweku is now 6 times as old as Amma, if Amma's age is X, Kweku's age will be 6 times X, which is 6X. I hope that is clear. Now let's move on. In 12 years' time, let's consider this. Let's say that somebody is 10 years now. Somebody is 10 years in 2018. The person is 10 years old in 2018. So in 2018, sorry, I'm going to clean this. Okay. Because I'm using the pointer, I can't write these things very well. Okay. So let's say that somebody is 10 years old in 2018. How old will the person be in 12 years? You see that in 12 years' time, the person will be 10 years, the 10 years that he is now, plus 12. That is going to be 22 years old. So if Amma is X years old now, how old do you think she will be in 12 years' time? It's going to be her age now, which is X, plus 12. In the same way, if Kweku is 6X years old now, in 12 years' time, he's going to be 6X plus 12. Because whatever age you are now, in 12 years' time, you are going to be that age plus 12 years. I hope that is clear. So the next point says that in 12 years' time, Kweku will be 2 times as old as Amma. But we first have to find their age in 12 years' time. So in 12 years' time, Ama's age will be x plus 3 because we know that now Ama is x years old. So in 12 years time, she will be x plus 12 years old. Ama's age now is x. In 12 years time, her age will be how old she is now, which is x plus 12. In 12 years time, Kweku's age will be 6x plus 12 because Kweku is 6x years old now. So in 12 years time, it will be 6x plus 12. I hope that is clear. Now, the question told us that, or the statement was that, in 12 years time, Kweku will be 2 times as old as Ama. So in 12 years time, Kweku's age will be 2 times Ama's age. Now, in 12 years' time, how old will be Kweku? Kweku will be 6x plus 12 years old. How old will be Ama? Ama will be x plus 12 years old. Now, 2 is multiplying x plus 12. Because x plus 12 is a binomial, you are going to put the binomial in the bracket. Then you bring the number outside the bracket here. So you are going to have 6x plus 12 is equal to 2 into bracket x plus 12. So we have formed this linear equation. We can now solve for x, where x is Ama's age. I hope this is clear. So I'm going to go through the whole process once again so that you get it. Okay. I'm going to go through the whole thing once again. Kweku is now 6 times as old as Ama. In 12 years' time, Kweku will be 2 times as old as Ama. How old are they now? The question is telling us to find the ages of Kweku and Ama. Because it's talking about 2 times, we are going to deal with those 2 times, now and in 12 years' time. So now, what we can say is that Kweku is 6 times as old as Ama. This statement means that Kweku's age is equal to 6 times Ama's age. So, if we let Ama's age be equal to x, or if we say that Ama's age is x, Kweku's age will be equal to 6 times Ama's age, which is x, and that will be 6 times x, which is 6x. So these are their ages now. Now Ama is x years old and Kweku is 6x years old. In 12 years time, as we said, whatever age you are now, in 12 years time is going to be your age now plus 12. So in 12 years time, Ama is going to be x plus 12 years old. Kweku is going to be 6x plus 12 years old because Ama is x years old. So in 12 years time, her age is going to be x plus 12. Kweku is 6 years old, 6x years old now. So in 12 years time, he is going to be 6x plus 12 years old now. The question told us that in 12 years time, Kweku will be 2 times as old as Ama. What that means is that in 12 years time, Kweku's age will be 2 times Ama's age. I hope that is clear. In 12 years time, Kweku's age will be 2 times Ama's age. For now, Kweku is 6 times as old as Ama. But in 12 years time, Kweku's age will be 2 times Ama's age. What is Kweku's age in 12 years time? It's 6x plus 12. What is Ama's age in 12 years time? It's x plus 2. We are saying that in 12 years time, 6x plus 12 will be equal to 2 times x plus 2. Now because 2 is multiplying x plus 2, which is a binomial, Ama's age in 12 years time is s plus 12, not s plus 2. So because 2 is multiplying s plus 12, which is a binomial, you have to put the binomial in a bracket. We explained this in algebra. We said that whenever you have a single term or another binomial multiplying a binomial, you put the binomial in a bracket. So here we put the binomial, which is s plus 12, in a bracket. Then we bring the number, which is 2, outside here. So we solve this linear equation. In solving this linear equation, what do? We have a bracket, so we expand the bracket. We expand the bracket, we get 6s plus 12 is equal to 2 times x will give us 2. 2 times 12 will give us 24. We group like terms, so we are going to have 6x minus 2s is equal to 24 minus 12. 6x minus 2s will give us 4x. 24 minus 12 will give us 12. To help us find x, we divide both sides by 4 and this x is going to give us 3. Now, what is x? When we started, we said that we are going to let Ahmed's age is equal to x. So here, Ahmed's age is x, and we have found x to be 3. So we can say that because Ahmed's age is x and we found x to be 3, Ahmed is 3 years old now. Now remember, x is Ahmed's age now. So Ahmed will be 3 years old now. That is what the question told us to find now. Their ages now, not their ages in 12 years time. So let's look at something. If Ahmed is x years old now, if Ahmed is 3 years old now, how old do you think she will be in 12 years time? It's going to be 3 plus 12, which is 15 years old. What is Kweku's age now? Kweku's age now is 6x. You found x to be 3, so you replace x with 3. So 6 times 3, and that will be 18. So we can say that Kweku is 18 years old now. So if Kweku is 18 years old now, how old do you think he will be in 12 years time? It's going to be 18 plus 12, which is 30. So in 12 years time, Kweku is going to be 30 years old. So we can say that, therefore, Amma is 3 years old now, and Kweku is 18 years old now. Okay, let's take the next question. Kwame is x years old now. So here, the question has even introduced the variable for us. So we have to use that. How old was Kwame? How old was he 7 years ago? How old will he be in 11 years from now? If his age 11 years, if his age in 11 years will be 3 times his age 7 years ago, how old is he now? So let's take our time and analyze this. Kwame is x years old now. So let's say that you are 17 years old now. How old were you 7 years ago? How do you find that? You subtract 7 from 17, right? So it means that you were 10 years old 7 years ago. If you are 17 years now, you got 10 because you did 17 minus 7. In the same way, if Kwame is x years old now, 7 years ago, he was x minus 7 years old. How that is clear? If he is x years old now, if you want his age 7 years ago, you have to subtract 7 from his age now, which is x. So it means that 7 years ago, he was x minus 7 years. I hope that is clear. Let's move on to the next part. How old will he be 11 years from now? He is x years old now. He is x years old now. In 11 years time, how old will he be? If you are 10 years old now, how old will you be in 11 years time? It's going to be 10 plus 11, which will be 21, right? So if Kwame is x years old now, in 11 years time, he is going to be s plus 11 years old. I hope that is clear. His age now plus 11 years will give us his age in 11 years time. So if his age now is x, his age in 11 years time will be s plus 11. So we've answered the part 2. Let's move on to the I part. His age in 11 years will be 3 times his age 7 years ago. Now let's look at it very carefully. If his age in 11 years will be 3 times his age 7 years ago, how old is he now? So it means that we have to find x. So we have to form a linear equation. So we use the statement here to form the linear equation. Now let's look at it. His age in 11 years will be 3 times his age 7 years ago. What this statement means is that his age in 11 years, which is s plus 3, is equal to 3 times his age 7 years ago. What is his age 7 years ago? His age 7 years ago is s minus 7. Now s minus 7 is a binomial. So if you are multiplying 3 by s minus 7, you have to put s minus 7 in a bracket. So the 3 will be outside, then you have s minus 7 in a bracket. So how this is clear. His age in 11 years time, which is s plus 11, is equal to 3 times his age 7 years ago. His age 7 years ago is x minus 7. So it's going to be 3 times x minus 7. Now once again, because x minus 7 is a binomial, I'll put x minus 7 in a bracket. So we are going to have x plus 11 is equal to 3 into bracket x minus 7. We have this linear equation, so we have to solve. So we expand the bracket. This will give us x plus 11 is equal to 3x minus 21, because 3 times x will give us 3x, 3 times 7 will give us 21. So from here we group like terms. So I'll keep x here, then bring 3x to this side. I'll keep minus 21 here, send 11 to this side. As at now, you should be conversant with how to solve this. X minus 3x will give us minus 2x. Minus 21 minus 11 will give us minus 32. We will divide both sides by minus 2, and s will give us 16. But what is s? S is Kwame's age now. What this means is that Kwame is 16 years old now. So if Kwame is 16 years old now, what it means is that 7 years ago he was, what this means is that 7 years ago he was 9 years old, because if you want his age 7 years ago, you have to subtract 9 from 16. What it also means is that in 11 years time he is going to be 27 years old, because you add 11 to his age now, which is 16. 16 plus 11 will be 27 years old. So whenever you are being given a question like this, you read the statement very, very carefully. You analyze the statement. You let a variable or a letter represent the unknown quantity. You form the linear equation. Then you solve the linear equation that you have in order to find the unknown quantity. Thank you for watching this video on linear equation, on all the other videos on linear equation. This is the end of linear equations. Pick more examples based on the videos that you've done, the type of examples that you've considered, and try your hands on them, especially linear equation, solving practical problems that involve the use of linear equation. There are a lot of examples out there, so try your hands on a lot of them. If you have any problems, interact with me on my social media handles and I'll help you to solve the question. In the next video, we are going to tackle the second part of our topic, which is linear inequalities. Bye-bye. We are on the topic linear equations and linear inequalities. In the previous videos, we have considered what linear equations are. In this video, we are going to consider the second part of our topic, which is linear inequalities. So let's learn more about linear inequalities. An inequality is a numerical statement which involves any of these signs: less than, greater than, less than or equal to, or greater than or equal to. In the video on Introduction to Linear Equations, we learned that equations are numerical statements or mathematical statements which involves an equal to sign. So linear inequalities, on the other hand, are numerical statements or mathematical statements which involves these inequality signs. So these are the inequality signs: less than, greater than, less than or equal to, or greater than or equal to. So for example, the expression 3x plus 1 is less than 4 is an inequality, and it is linear because the highest power of the variable in this inequality is 1. In the video on Introduction to Linear Equations, we explained this property. The expression 4y minus 2 is greater than y is also an inequality because it involves the inequality sign, and it's linear because the highest power of the variable, which is y, is 1. In the same way, the expression 5x plus 2 is less than or equal to 2x plus 1 is also linear, or it's also an inequality because it contains the inequality sign. And x plus 1 is greater than or equal to 4 is also an inequality. Let's learn more about inequalities. In solving linear inequalities, remember that when a number or term crosses the inequality sign, the sign of the term changes. That is, positive becomes negative and negative becomes positive. When we are learning about linear equations, we said that when a number or term crosses the equal to sign, the sign changes. It's the same for linear inequalities. The process for solving linear inequalities are almost the same as the processes for solving linear equations. Another thing you need to know about linear inequalities is that when you divide both sides of the inequality by a negative number, the direction of the inequality changes to the opposite direction. That is, less than becomes greater than, and vice versa, or greater than becomes less than, and less than or equal to becomes greater than or equal to, and greater than or equal to becomes less than or equal to. If you don't understand this statement here, we are going to use it to solve some more examples, so you are going to get it. What you need to know is that as soon as you divide through the inequality by a negative number, the sign of the inequality changes. Thank you for watching this video on Introduction to Linear Inequalities. See you in the next video where we will begin to solve questions on linear inequalities. Bye bye. We are on the topic linear inequalities. In the previous video, we considered what linear inequalities are. In this video, we are going to consider how to solve linear inequalities. Just as we did for linear equations, we are going to divide linear inequalities into types. So in this video, we will consider how to solve the first type of linear inequalities. The first type is where you have the letter on only one side of the inequality. Here are 4 examples for us to solve. We are going to solve 2 examples in this video, then we will solve the next 2 in the next video. So we are being told to find the truth set of the following, and we will have to illustrate our answer on a number line. Let's take them one after the other and see how we are going to do this. So we pick the first one. 4x plus 2 is less than 14. We are supposed to solve this linear inequality. The processes are the same as what we did for linear equations. So here, what you have to do is to group like terms. We know that 2 and 14 are like terms. So we group 2 and 14 on one side of the inequality. So what I'm going to do is that I'll leave 4x here, then I'll take 2 from this side and bring it here. As we said in the previous video, whenever a number or a term crosses the inequality sign, the sign of the number changes. So since 2 is positive here, as soon as it crosses this inequality sign, 2 becomes negative. So I'll leave 4x here. We have the less than sign. 14 is already here, so you write 14. Then when 2 crosses the inequality sign from this side to this side, it becomes negative. So I'm going to have 14 minus 2. Now we move on. We have 4x, which will already be there. Then 14 minus 2 will give us 12. In linear equations, we said that when you get to this stage, you divide through by the number attached to x. You do the same thing here. So here the number attached to x is 4. So you divide through these inequalities by 4. You divide through this inequality by 4. So you divide both sides by 4. We divide 4x by 4. We divide 12 by 4. 4 will cancel 4. So when you come here, 4 will cancel 4. Then 4 will cancel 12 3 times, which means that we are going to have s is less than 3. So we have solved this linear inequality. But the question told us to find the truth set. We've learned how to find the truth set. To find the truth set, we say that the truth set is you open your curly brackets, then the variable, which is x, is such that x is less than 3, as you have here. So we have written the truth set for this inequality. The question also told us to illustrate our answer on a number line. So to illustrate your answer on a number line, you draw a simple number line like what I have here. Make sure that the number in your answer is on the number line. This is what I mean. Here, the number in our answer is 3. So make sure that 3 is on the number line. So my number line contains -1, -2, -1, 0, 1, 2, 3. You should also make sure that the differences between your numbers on the number line are the same. You don't necessarily have to write a lot of numbers like this. You can write just 3 or 4 of them. I just use this to explain how you are going to do it to you. So I chose -1, -2, -1, 0, 1, 2, 3. So you can see that the differences between them are the same. From here to here is 1, from here to here is 1, from here to here is 1, and it continues. Now, after you've done this is what you do. You draw a line from your answer. You draw an arrow from your answer. The direction of the arrow must be the same as the direction of the inequality sign. Now you can see that this inequality sign is less than, is going this way. So it means that your arrow must also be in the same direction. So you see that the direction of the arrow will be the same as the direction of the inequality sign. Your line must be from your answer in the direction of the inequality sign. So our answer is 3. The direction of an inequality sign is less than, so you draw your arrow in that direction. Then after that, you draw some small circle on top of your answer like this. So this is how to illustrate this answer on a number line. Let's take the next question. We have -4 minus 3x is less than or equal to 20. So once again, we group like terms. In grouping like terms, I always like to keep my terms with the variable or x on the left hand side, then the ones without the variable on the right hand side. You can do it the other way around. You will get the same answer. But I prefer keeping my terms with the variables on the left hand side. So that's what I'm going to do. So I'm going to keep -3x here. Then I'll send my -4 from this side to this side. So as soon as I keep -3x here, I will take -4 from this side. It's crossing the inequality sign, so it becomes positive. So I'm going to have -3x less than or equal to 20 plus 4. So we continue. -3x is less than or equal to 20 plus 4 give us 24. Now when you get to this stage, you divide through by the number attached to x. Here, the number attached to x is -3. So you are going to divide through the inequality by -3. Now you have to take note of something here. In the introductory video, we said that when you divide through by a negative number, the direction of the inequality changes. So here, as soon as we divide through by -3, the inequality changes from less than or equal to greater than or equal to. So that is the meaning of that statement. As soon as you divide through by a negative number, the direction of the inequality changes. So here it was less than or equal to. It will change to greater than or equal to because we have divided through by a negative number. So here, -3 will cancel -3. We are going to have x. You have your greater than or equal to 24 divided by -3 will give us -8. You present your answer as a truth set. So the truth set is x is such that x is greater than -8. The question said we should illustrate our answer on a number line. So we draw a number line. On the number line, make sure that the number in your answer is on the number line. The number in our answer is -8. So you should make sure that -8 is on the number line. Then add about 3 to 4 numbers. And also make sure that the differences between the numbers are the same. So here from -8 to -4 is 4. From -4 to 0 is 4. From 0 to 4 is 4. So make sure that the differences between them are the same. You can end at 0 or 4. It doesn't change anything. So we draw a line from -8, which is our answer, in the direction of the inequality sign. Here the inequality sign is pointing this side, is greater than, so you draw from -8 in that direction. Then you draw a small circle on top of the answer. Now here, because you have less, greater than or equal to, you have to shade the circle that you draw on top of the answer. If the sign is greater than or equal to or less than or equal to, you shade the circle. If it's only less than or greater than, you don't shade the circle. Thank you for watching this video on linear inequalities. See you in the next video where we will take more questions on linear inequalities. Bye bye. We are on the topic linear inequalities. In the previous video, we considered how to solve some examples on the first type of linear inequalities. In this video, we are going to consider two more examples. So, we will pick the first one, which is 7x minus 16 greater than 12. So, we are supposed to solve this inequality. As we did in the previous video, the first thing you have to do here is to group like terms. We can see that -16 and 12 are like terms. As I said, I always like to keep the terms with the variables on the left hand side and the terms without the variables on the right hand side. So I'm going to keep 7x here, then I group 16 and 12 on this side, which is the right hand side. So I'll keep 7x here, 12 is already here, so we will keep it there. Now this 16 is minus. As soon as a number or a term crosses the inequality sign, it changes the sign to the other sign. So if it's negative, it becomes positive. If it's positive, it becomes negative. Here 16 is negative, so when it crosses the inequality sign, it becomes positive. So we are going to have 7x is greater than 12 plus 16. So we are going to get 7x is greater than 12 plus 16 is 28. When you get to this level, you divide through by the number attached to the variable. So here we are going to divide through by the number attached to the number attached to x, which is 7. So you divide through by 7. We divide both sides by 7, so 7x divided by 7, 28 divided by 7. 7 will cancel 7, you will get x. 28 divided by 7 will give us 4. So the question said we have to write the truth set, or you have to find the truth set. So you write the truth set as x is such that x is greater than 4. By this time, you should know how to write the truth set for your answer. The question also told us to illustrate our answer on a number line. So as I said, you draw a simple number line. Make sure that the number in your answer is on the number line. The number in our answer is 4. So make sure that 4 is on the number line. Then also make sure that the differences between the numbers are the same. So here I chose 2. So from 4 to 6 is 2, from 6 to 8 is 2, from 8 to 10 is 2. Now after you finish with that, you draw a line from your answer in the direction of the inequality sign. So here the inequality is pointing this side, so you draw the arrow in the direction of it. Remember that the line that you draw must be an arrow, so you draw the arrow in that direction. Then after that, you draw a small circle on top of your answer. Now, because this is greater than, not greater than or equal to, you are not going to shade the circle. If the answer was x is greater than or equal to 4, then you will shade the circle. Because it's only greater than, you are going to leave the circle as it is. Let's pick the next example. Minus 5x plus 4 is greater than or equal to 24. Once again, you group like terms. So in grouping like terms, I want to keep the term with x, or the variable, on the left hand side. So I will keep negative 5x here. 4 is positive, so it crosses the equal to sign to this side, becomes negative. So I'm going to have minus 5x is greater than or equal to 24 minus 4. Minus 5x is greater than or equal to 24 minus 4 is 20. when you get to this stage, you divide through by the number attached to the variable. The variable is x. The number attached to it is -5. So you divide through by -5. But remember that as soon as you divide through by a negative number, the sign of the inequality, the direction of the inequality changes. So if it's greater than or equal to, it becomes less than or equal to. So here, if you divide through by -5, the sign which is greater than or equal to changes to less than or equal to. I hope that is clear. -5 will cancel -5, so we have x. We have a less than or equal to, then 20 divided by -5 will give us -4. The question said we should write the truth set. So the truth set will give us s is such that x is less than or equal to -4. It also said we should illustrate our answer on a number line. So you draw a simple number line. So I'm beginning from -16, -12, -8, -4. You just draw a simple number line, but make sure that your answer is in the number line. So from here, I'll draw a line from -4 in the direction. That's very important, in the direction of the inequality sign. So here the inequality is pointing this way, so I'll draw an arrow from here in this direction as we have here. Then you draw a simple small circle on top of your answer. Because it is less than or equal to, you shade the circle. Thank you for watching this video on linear inequalities. See you in the next video, where we will learn how to solve the second type of linear inequalities. Bye-bye. We are still on the topic linear inequalities. In the previous video, we saw how to solve the first type of linear inequalities. In this video, we are going to take a look at how to solve the second type of linear inequalities. So we move on to type 2 of linear inequalities. Type 2. In this type of linear inequalities, you have the letter on both sides of the inequality. So you have been given 3 questions here, and we will take them one after the other. We will solve the first question in this video. The first question says that we should solve 7x minus 1 is less than or equal to 15x minus 15 and illustrate our answer on a number line. So here's the question we are supposed to solve. 7x minus 1 is less than or equal to 15x minus 15. Straight away, the first thing that we need to do is to group like terms. As I always say, I would like to group the terms with the variables or with the terms with x on the left side of the equation of the inequality. Then I group the terms without the variables on the right side. So here, I'm going to take 15x from this side and bring it here. Then I will take minus 1 from this side and I'll send it over here. So this is what's going to happen. I'm going to have 7x. I'll keep the 7x here. 15x here is positive. So when it crosses the inequality sign to this side, it becomes negative. So I'm going to have 7x minus 15x. Then we have the sign less than or equal to. We have minus 15 here already, so I'll keep that. Now 1 is negative, so when it crosses the inequality sign to this side, it becomes positive. So I'm going to have plus 1. 7x minus 15x. If you watch the video on addition and subtraction of algebraic expressions, we know that 7x minus 15x is minus 8x. We have less than or equal to. Minus 15 plus 1 is minus 14. From here, we divide through by the number attached to x. The number attached to x is minus 8. So we are going to divide through this inequality by the number minus 8. Remember, we said that if you divide through by a negative number, the sign of the inequality changes. So as soon as we divide through, or we divide both sides by minus 8, the sign changes from less than or equal to greater than or equal to. Minus 8 will cancel minus 8. So we are going to have x is greater than or equal to Minus 14 divided by minus 8 is 7/4. So we have solved the inequality. Now the second part of our question says that we should illustrate our answer on a number line. Now how do we do this? First, you draw a line like this with the arrows at the end. Now, as I told you in the previous videos, make sure that the number in your answer appears on the number line. So here I'm going to start from that number. That the number in our answer is 7/4. So I'm going to write that on our number line, 7/4. Looking at the inequality sign, it shows that the arrow will be moving in this direction. Now this is what I mean. Looking at the inequality sign, it means that the line that we are going to draw on top of the inequality will be moving in this direction. We know from our number line that if you have a number line like this, if you have a line like this, sorry, I'm going to clean this so that you get it very well. Okay. So if you have a line like this, our number line, let's say that this is our number line, then this is the line that divides it. Moving from this side to this side, here is the positive side and here is the negative side. So what this means is that if you are moving from this end here to this side, which the inequality sign is showing us that will be our direction, the numbers are positives. If you are moving to the other side, the numbers are negative. Now, because the arrow is showing us that we'll be moving in this direction, we will not concern ourselves with the numbers here. We are only going to concern ourselves with the numbers that will be moving in this direction. So from 7/4, what will be our next number? Now, this is the trick that I use. To get the next number, just add 7/4 to this 7/4. So we are going to add 7/4 to 7/4 in order to get the next number. So to get the next number, we are going to have 7/4. We add it to another 7/4. Okay. Sorry. So 7/4. We add it to 7/4, and we are going to get 7/2, which means that our next number on the number line must be 7/2. It's always good to list about 2 or 3 numbers. So I'm going to add another number to this number line. Now, to add another number to this number line, what you have to do is that add 7/4 to this new number, which is 7/2. So I'm on my calculator. I'm going to add. So I already have 7/2. So 7/2. Then I will add 7/4, which is our original number. I'll add it to it, and that is giving us 21/4. So our next number on the number line is 21/4. So you get it right. The first number is 7/4. Add 7/4 to 7/4. You get the next number. Add another 7/4 to this new number. So if you add 7/4 to the new number, which is 7/2, you are going to get 21/4. If you have about 3 numbers like this, it's okay. Now, to draw the number line, all you need to do is to draw a line on top of the number in your answer, which in this case is 7/4. So you draw a line from 7/4 in this direction. Then we are going to shade the circle on top of the answer because it is greater than or equal to. Thank you for watching this video. See you in the next video where we will take another question on type 2 of linear inequalities. Bye-bye. We are on the topic linear inequalities. In the previous video, we took a question on solving type 2 of linear inequalities. In this video, we are going to solve another question on type 2 of linear inequalities. So let's look at the question. We are being told to find the truth set of 1 minus 7x is greater than or equal to x plus 3. And we are supposed to illustrate our answer on a number line. So let's take the question. 1 minus 7x greater than or equal to x plus 3. As I always say, I always want to group the terms with the variables on the left hand side, then I group the terms without the variables on the right hand side. So I'm going to group the terms with x on this side, then I group the terms without x on the other side. You can choose to do it the other way around, it will also work. but for simplicity's sake, that's what I want to do. So I'm going to stick to that. So here what I'll do is that because I want to do that, I will keep minus 7x on this side of the inequality. Then I bring x from this side to join it. I'll keep 3 here. Then I'll take 1 from this side and send it over there. I hope that is clear. So if I'm keeping minus 7x here, I'm going to have minus 7x. X here is positive. So when it crosses the inequality sign to this side, it becomes negative. So I'm going to have minus 7x minus x. You bring your sign greater than or equal to, 3 is already here. So 3, 1 is positive. When it crosses the inequality sign to this side, it becomes negative. So I'm going to have 3 minus 1. From the video on addition and subtraction of algebraic expressions, we saw that minus 7x minus x will give us minus 8x. Then we bring our sign greater than or equal to 3 minus 1 will give us 2. If you divide from here, we are going to divide both sides by the number attached to the variable. The number attached to the variable in this case is minus 8. On the video on introduction to linear inequalities, we said that if you divide through by a negative number, the direction of the inequality sign changes. So here, as soon as we divide through by negative 8, the inequality sign changes from greater than or equal to less than or equal to. From here, minus 8 will cancel minus 8. Then we have our less than or equal to sign. 2 divided by minus 8 will give us minus 1 over 4. So we solved the question, but the question said that we should find the truth set. So you write the truth set for it. The truth set is s is such that x is less than or equal to minus 1 over 4. Now we move on to the second part of our question. It said that we should illustrate our answer on a number line. So here is what you are going to do. You draw the arrow, your line for the number line here. So we draw it here. Now I'm going to start my numbers from the number in the answer. The number in the answer is negative 1 over 4. So I'm going to start listing the numbers from there. So the first one is negative 1 over 4. Now look at the inequality sign very well. We can see that from here, looking at the inequality sign very well, it means that the numbers will be moving in this direction, because that is the direction the inequality sign is pointing to. So our arrow will be moving in that direction. So the numbers that we will be listing will also be moving in that direction. We've listed the first one as minus 1 over 4. So what will be the next one? As I told you in the previous video, we know that if you draw your number line like this, and let's say here is the division, this side is positive, then this side is negative. So from here, we keep adding the numbers to get the next number. Here, because it's negative, you are going to subtract the numbers to get the next number. Now, this is what I mean. We can see that the first one here is negative 1 over 4. Now, because we are moving in this direction, to get the next number, subtract 1 over 4. In the previous video, we added because we are moving in this direction. But because in this video, we are moving in the opposite direction, we are going to subtract. So if you are moving in this direction, you subtract. If you're moving in that direction, you add. So here, the first number is negative 1 over 4. So if you want to get the next number, we subtract 1 over 4 from this number. So that's what we are going to do. So to get the next number, we already have negative 1. We already have negative 1 over 4. So to get the next number, we have to subtract 1 over 4. So we subtract 1 over 4 from it, and that will give us negative 1 over 2. So it means that the next number is negative 1 over 2. Now to get the next one, you subtract negative 1 over, you subtract 1 over 4 again. So we are going to keep on subtracting till we get to the limit that we want. So here I'm going to list about 2 or 3 more. So to get the next number, what you do is that you go onto your calculator again, Now our new number is negative 1 over 2. So negative 1 over 2. To get the next number, you subtract 1 over 4 again, and that will give us negative 3 over 4. So negative 3 over 4. To get the next number again, you subtract 1 over 4 from the new number. So if you want to do that, negative 3 over 4. So you subtract 1 over 4 from it to get the next number. So 1 over 4, and that will give us 1. So it means that the next number is 1. So that's what you keep on doing. Now here you could have ended at negative 3 over 4. If you list 2 or 3 more numbers, it's okay. So we now have our number line here. So what we are going to do is that we now draw the lines. As I said, you draw the line from the answer. The answer is negative 1 over 4. In the direction of the inequality sign, it's pointing this way. So you draw the line in that direction. You draw a small circle on the answer. So that's what you do. Now, if it is less than or equal to or greater than or equal to, you shade the circle. Because here is less than or equal to, you shade the circle as we have in this answer. Thank you for watching this video on type 2 of linear inequalities. See you in the next video where we will take another question on solving type 2 of linear inequalities. Bye bye. We are still on the topic linear inequalities. In the previous video, we looked at an example on type 2 of linear inequalities. In this video, we are going to consider another example. So let's take the question. Find the truth set of the linear inequality 14x plus 30 is greater than or equal to 2x plus 6 if x belongs to the set negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2. Illustrate your answer on a number line. Now this question looks a little bit different from the ones that we've been doing. So we are going to break them into parts, then we will solve it. So let's consider the first part. The first part says that we should solve the inequality given to us. That one we are familiar with it. So let's do it. So let's solve the first part. We are supposed to find the truth set of the linear inequality, and that's what we are going to do. So here is the inequality. 14x plus 30 is greater than or equal to 2x plus 6. We group like terms as we've been doing all along. So if I'm grouping like terms, as I said, I always want to keep the terms with the variables on the left hand side, then I'll keep the terms without the variables on the right hand side. So I'm going to have 14x minus 2x is greater than or equal to 6 minus 30. We've done a lot of these examples, so you should be conversant with grouping like terms by now. 14x minus 2x will give us 12x greater than or equal to 6 minus 30 will give us minus 24. When we get to this level, we say that you divide through by the number attached to the variable. So here the number attached to the variable is 12. So we divide both sides by 12. Now because we are dividing through by a positive number, the sign of the inequality, the direction of the inequality will not change. It will be the same because we are dividing through by a positive number. 12 will cancel 12, so you have x here. Minus 24 divided by 12 will give us minus 2. So we've solved the inequality. We solve it and we got x is greater than or equal to minus 2. Now let's move on to the next part of our question. The question says that x belongs to this set. So this is the set given us. The set given us is this set. And what the question is telling us that this value or this answer that we have here, the answer x, it belongs to this set. What that means is that x is greater than or equal to negative 2. Under normal circumstance, that is a range of values. It means that all numbers greater than or equal to negative 2. But the question is telling us that this x belongs to this set. So the answers can be found in this set alone. So if you want to find the truth set will be values in this set that are greater than or equal to -2. I hope that is clear. In the previous examples that we were finding, a set was not given to us, so our answers will go on up to infinity. But here the set has been defined for us. The set is telling us that the value of x that you find is in this set. So what this means is that the answers for x are numbers in this set that are greater than or equal to -2. So if you want to find the truth set of this inequality, it is numbers in this set that are greater than or equal to -2. So you list the numbers in this set, or the members in this set that are greater than or equal to -2. And those members are -2 itself. Since it's greater than or equal to -2, -2 will be included. So -2 itself, -1, 0, 1, and 2. Remember that -3 is not greater than -2. So the members in this set that are greater than or equal to -2 are -2 itself, -1, 0, 1, and 2. So the truth set is -2, -1, 0, 1, and 2. So we've dealt with the second part of our question. Now the last part says that we should illustrate our answer on a number line. We should illustrate our answer on a number line. Here, our number line is pretty defined for us because the set has been given us. So from -6 to 2. So you draw a number line that contains all these members. So from -6, from -6, -5, -4, -3, -2, -1, 0, 1, 2. So you draw a number line that contains this set. Now we have to illustrate this truth set on this number line. The truth set is -2, -1, 0, 1, 2. So what you do is that you go onto the number line, then you draw circles on those numbers. So you draw a circle on -2, then you shade it. You draw a circle on -1 and you shade it. You draw a circle on 0 and you shade it. You draw a circle on 1 and you shade it. Then finally you draw a circle on 2 and you shade it, to indicate that those are the answers to our inequality, or those are the solution to our inequality. So it's pretty simple. If the set is defined for you, your answer is going to be the members in the set that satisfies the answer that you got in the question. So here the answer we got was s is greater than or equal to -2. So what this means is that the answer to this inequality are members in this set that are greater than or equal to -2, and those members are -1, -2, -1, 0, 1, 2. And this is how to illustrate it on the number line. Thank you very much for watching this video on type 2 of linear inequalities. Pick more examples on type 2 of linear inequalities and try your hands on them. In the next video, we are going to consider how to solve the third type of linear inequalities. Bye-bye. We are still on the topic linear inequalities. In the previous video, we looked at solving type 2 of linear inequalities. In this video, we are going to consider solving the third type of linear inequalities. Now, in the third type of linear inequalities, you will see that the inequality involves a bracket. So when there's a bracket in the inequality, how are we going to do it? We have about 4 questions here, and we are being told to find the truth sets. We will take them one after the other, then we will see how to solve it. We are going to solve the first 2 in this video, then in the next video, we will consider the next 2. So let's pick the first one. We have 2 into bracket 3x minus 5, bracket close, is greater than 6 plus 2x. And we are being told to find the truth set of this inequality. Now, if it involves a bracket, what you have to do is that you have to open the brackets. Now, how do you open the bracket? You multiply the term inside the bracket with the term outside the bracket. This is what I mean. You multiply 3x and minus 5 by the term outside the bracket, which is 2. So 2 will multiply each term in the bracket. So to expand this bracket, you are going to have 2 times 3x, which will give us 6x, then 2 times minus 5, which will give us minus 10. You have 6 plus 2x since you don't have any bracket here. From here, it becomes type 2 of linear inequalities. So what you do is that you group like terms, then you simplify. As I said, I want to keep the terms with x on the left hand side, which is here. Then I'll keep the terms without x on the right hand side, which is here. So I'll keep 6x here, then I'll bring 2 from this side to join it. I'll keep 6 here, I'll take 10 from this side, and I'll send it over there. So when that happens, I'm going to have 6x. 2x is positive, so when it crosses to this side, it becomes negative. So 6x minus 2x. I'll keep 6 here. 10 is positive. When it crosses to this side, it becomes 10 is negative. Sorry. When it crosses to this side, it becomes positive. So 6 plus 10. 6x minus 2x will give us 4x. 6 plus 10 will give us 16. So when you get to this level, you've seen that you have to divide through by the number attached to the variable, which is x. So here the number attached to x is 4. So you divide both sides of the inequality sign by 4. So if you are dividing through by 4, you are going to have 4x divided by 4, 16 divided by 4. 4 will cancel 4, so you are going to have x at this side. 16 divided by 4 is 4. So the truth set of this inequality is s is such that x is greater than 4. Let's look at the next question. So here we have the brackets on both sides of the inequality. So we have 7 into bracket x plus 2 less than 5 into bracket x plus 2. Nothing changes. You do it the same way as we were doing in the previous one. So you are going to multiply through here by 7. Here you multiply by 5. So you are going to have 7 times x, which will give us 7x. 7 times 2, which will give us 14. Then you bring your sign to less than. 5 times x will give us 5x. 5 times 2 will give us 10. From here, it becomes type 2 of linear inequalities. So we group like terms and we simplify. I'm going to have 7x minus 5x is less than 10 minus 14. So I took 5x from this side. Since it's positive, when it comes here, it becomes negative. Then I kept 10 here and I sent 14 over there. So 10 is positive. 14 is positive here, but when it crosses to this side, it becomes negative. So minus 14. So I'm going to have 7x minus 5x will give 2x. 10 minus 14 will give us minus 4. You divide through by 2. So 2x divided by 2 minus 4 divided by 2. 2 will cancel 2 to give us x. Minus 4 divided by 2 give us minus 2. So the truth set is s is such that x is less than minus 2. Thank you for watching this video on type 3 of linear inequalities. In the next video, we are going to consider some examples on type 3 of linear inequalities. Bye-bye. We are still on the topic linear inequalities. In the previous video, we saw how to solve type 3 of linear inequalities. In this video, we are going to take 2 more examples on type 3 of linear inequalities. So let's pick the first example. We have 3 into bracket x minus 4 is less than or equal to 4 into bracket x plus 3. So as we did in the previous video, we are going to do the same thing here. We expand the bracket or we open the bracket. So in opening the bracket, 3 will multiply x to give us 3x. 3 will multiply minus 4 to give us minus 12. Then we bring our inequality sign, which is less than or equal to. 4 will multiply x to give us 4x. 4 will multiply 3 to give us 12. From here, it becomes type 2 of linear inequalities. So you group like terms and you simplify. I'll keep 3x here, then I'll bring 4 over. I'll keep 12 here and I'll send this 12 over. So I'm going to have 3x minus 4x, since this 4x is positive. So when it crosses to this side, it becomes negative. Then less than or equal to, now this is 12, which is positive. This 12 is negative. So when it crosses to that side, it also becomes positive. So plus 12. 3x minus 4x. If you watch the video on addition and subtraction of algebraic expressions, you will see that 3x minus 4x is minus x. Then less than or equal to 12 plus 12 is 24. Remember, the question said that we should find x, not minus x. So it means that we have to make x the subject. Now, if you have minus x, this means is that the coefficient of x is 1. We are not writing it because it's 1. So if you want to find x, you have to divide through by the number attached to x, which is minus 1. So here you divide this side by minus 1 and you divide this side too by minus 1. Now, as soon as you divide through by minus 1, you will see that this minus will cancel this minus, which will give you x over 1, which is the same as x. So we now have x there. Now remember that we said whenever you divide through by a negative number, the direction of the inequality changes. So here it used to be less than or equal to, but because we divided through by a negative number, which is negative 1, it will change to greater than or equal to. So minus x divided by minus 1 will give us x. 24 divided by minus 1 will give us minus 24. So remember that whenever you get to this level and you have minus x is less than or equal to a number, don't leave your answer like that. Divide through by negative 1 in order to get x. So we have x is greater than or equal to minus 24. You can see that in this example and all the other examples, I've been using x as the variable. The variable can be a, can be b, can be n. It can be any other alphabet. I use x because it's simple to handle. That's why. Let's consider the next one. So here the truth set is x is such that x is greater than or equal to minus 24. In the next one, the question is 4 into bracket x plus 2. 4 into bracket x plus 2 is greater than 6 plus 3 into bracket x minus 1. So once again, you open the brackets. So in opening the brackets, we are going to have 4 times x, which will give us 4x. 4 plus 4 times 2, which will give us 8. We have 6 here, so 6 will come. Then we come to this side. So the number in front will multiply through. So 3 times x, which will give us 3x. 3 times minus 1, which will give us minus 3. Now remember, the term in front of the bracket is 3. So that is what you are going to use to open the brackets. Now from here, it becomes type 2 of linear inequalities. So we simplify. So I'm going to send 3x over to this side. Then I'll send 8 to that side, since they are like terms. So I'm going to have 4x minus 3x here is positive. The sign in front of it is plus, so it's positive. So when it crosses to this side, it becomes negative. Now I have 6, I have minus 3 here. Then 8 is positive. So when it crosses to that side, it becomes negative. 4x minus 3x. From the video on addition and subtraction of algebraic expressions, 4x minus 3x is x. Now 6 minus 3 minus 5 will give us minus 3 minus 8 will give us minus 5, because 6 minus 3 is 3 minus 8 will give us minus 5. So x is greater than minus 5. The truth set is s is such that x is greater than minus 5. Thank you so much for watching this video on type 3 of linear inequalities. In the next video, we are going to consider how to solve the fourth type of linear inequalities. Bye-bye. We are still on the topic linear inequalities. In the previous video, We saw how to solve type 3 of linear inequalities. In this video, we are going to study how to solve type 4 of linear inequalities. So in type 4 of linear inequalities, you will see that the inequality involves a fraction. Now, if the inequality involves a fraction, how do we solve it? We have 4 examples here. We are going to take them one after the other. We will solve the first one in this video, then the remaining ones in the subsequent videos. So let's look at the first one. We have 1 over 3 into bracket 5x minus 4 is greater than x plus 11 over 12. So if you have this, how do we solve it? Now you can see from here that it involves a fraction. If the inequality given to you involves a fraction, the first thing you need to do is to first identify the fractions. So in this inequality given to us, the fractions are 1 over 3 and 11 over 12. Now, after you've identified the fractions, the next thing you need to do is to find the LCM of the denominators. LCM stands for least common multiple. If you watch the video on sets, we explain how to find the LCM of a set of numbers. So here you find the LCM of the denominators. The denominators of the fractions are 3 and 12. So you find the LCM of 3 and 12. If you find the LCM of 3 and 12, you are going to get 12. So, as I said, if you want to know how to find the LCM of a set of numbers, watch the video on sets and you get to know how to find the LCM. So, LCM of 3 and 12 is 12. Now, after you found the LCM, the next thing you need to do is to identify the terms in the inequality. The terms in the inequality. Here, the terms in this inequality are this first one, so the whole thing here is a term. This one is a term. Now, x is also a term. Then 11 over 12 is also a term. So this whole thing is a term, x is a term, and 11 over 12 is also a term. In the video on introduction to algebraic expressions, we said that terms are separated by addition or subtraction sign. Now here we can see that this one is in the brackets. Between 1 over 3 and the one in the bracket is multiplication. So it means that the whole thing is a term. X is separated from 11 over 12 by an addition sign. That means that x is a term on its own. Then 11 over 12 is also a term on its own. So let's go over it again. We have found the fractions. We have been able to find the LCM with the denominators. We have been able to identify the terms in the inequality. Now, let's begin to solve the question. What you do is that, so we now know that the LCM is 12. What you do is that you multiply each term, the term that you identified, you multiply each of them by the LCM. So you multiply each term by the LCM. What this means is that we are going to multiply this whole thing here by 12. We multiply x by 12 and we multiply 11 over 12 by 12. So this is what is going to happen. We are going to have 12 times this thing here, which is 1 over 3 into bracket 5x minus 4. So 12 times this term. Then we move on to the next term, which is x. So 12 times x, or s times 12. You move on to the next term, which is 11 over 12. You multiply that one by 12. So 12 times 11 over 12. From here, we simplify. 3 will cancel itself 1. So 3 will cancel itself 1. And cancel 12 4 times. Now, 12 will cancel 12 once. So from here, we are going to have 4 times 1, which will give us 4. So 4 times 1, then into bracket 5x minus 4, then greater than x times 12 is 12x plus 12 has cancelled 12, so we have 1 here. So 1 times 11 to give us 1 times 11. Now, 4 times 1 will give us 4. So 4 into bracket 5x minus 4 is greater than 12x, which we already have. 1 times 11 will give us 11. So from here, you see that it becomes type 3 of linear inequalities. So when you go to type 3, what do? We open the brackets. So we are going to have 4 times 5x, which is 20x. 4 times 4 will give us 16. Now, because it's minus, so minus 16, then greater than 12 plus 11. 12x plus 11, sorry. From here, it becomes type 2 of linear inequalities. So we group like terms and we simplify. I'm going to bring 12x here, then I'll take 16 from this side and send it to that place. So we are going to have 20 minus 12x is positive, so when it crosses to this side, it becomes negative. So 20 minus 12x is greater than, I'll keep 11 here, 16 is negative. When it crosses to this side, it becomes positive. So 20x minus 12x will give 20x minus 12x will give us 8x. Then 11 plus 16 will give us 27. Now when you get here, what do? This is like type 1 of linear inequalities. We said that when you get here, we divide through by the number attached to the variable. The number attached to the variable is 8. So we divide both sides by 8. 8 will cancel 8 to give us x, then greater than 27 over 8. Now when you get our answers like this, usually in linear inequalities, when you have our answers in fractions like this, we want to leave our answers in mixed numbers or mixed fractions. I'm going to show you how you can use your calculator to get your answer in mixed number or mixed fraction. So if you want to do that, just switch on your calculator. Now you press the fraction that you have on your calculator. So here I'm having 27 divided by 8. Then you press equal to. You see? So we have 27 over 8 on your calculator. We want to change this to mixed fraction or mixed number because that is how we want to represent our answer. Now to do that, this is what you do. Remember, if you press 27 over 8 on your calculator, press equal to, such that you have 27 over 8 on your calculator also at this side. So you have one here, then you have the other one here. Now you press shift, then you press on this button. You see there's a button written as X, then there's a sign between them and D. You press on that button, S to D, you press on that button. Now as soon as you press on that button, the calculator will change your answer from your improper fraction that you have to your mixed number. So if you change it, you are going to get 3 whole number 3 over 8. We usually want to represent our answers like this. So 27 over 8 will give us 3 whole number 3 over 8. Now this is the answer to our question. Thank you for watching this video. In the next video, we are going to solve another question on type 4 of linear inequalities. Bye-bye. We are still on the topic linear inequalities. In the previous video, we looked at an example on solving type 4 of linear inequalities. In this video, we are going to consider another example. So let's look at the question for this video. We have 2 over 3 into bracket 3x minus 5 plus 3 into bracket x plus 2 is greater than 32 whole number 2 over 3. As I said, whenever the inequality involves a fraction, the first thing you need to do is to first identify the fractions in the inequality. So here the fractions are 2 over 3 and 32 whole number 2 over 3. Now because we have a mixed fraction or a mixed number, your first step is to convert the mixed number or the mixed fraction to improper fractions. In the video on fractions, we learned how to do that. So that's the first thing you need to do here. So convert the mixed number or the mixed fraction to improper fraction. So you are going to convert 32 whole number 2 over 3 to improper fraction. Now when you do that, you will see that it's going to give us 3 times 32 plus 2, and that will give us 98 then over 3. So we have our fraction the way that we want it. Now, after you are done with that, you find the LCM of the denominator. So here the two fractions are now 2/3 and 98/3. So you find the LCM of the denominators. The denominators are 3 and 3. LCM of 3 and 3 is 3. So we have our LCM. After you have the LCM, the next thing you need to do, so I'm going to clean this. Okay, so after you have the LCM, which is 3, so LCM here is 3. After you have the LCM, the next thing you need to do is to identify the terms in the inequality. The terms in the inequality. As I said, terms are separated by addition or subtraction. So here, this one here is a term since they are written together and there's no addition or subtraction between them. So this is one term. This one here is also a term. The reason being that this one here and this one here are being separated by addition. So this is one term, this is another term. Then when you come here, this one is also another term. So you have found the LCM. You have been able to identify the terms. The next step is that you multiply each term by the LCM. You multiply each term by the LCM. So this is what's going to happen. You are going to multiply this term here, which is 2/3 into bracket 3x minus 5 by the LCM, which is 3. Then when you come here, you multiply this term, which is 3 into bracket x plus 3 by the LCM, which is 3. So 3 times this term. Then you multiply this term also by 3. I hope that is clear. So from here, you cancel out. So if you are canceling out, you can see that if you are canceling out here, you can see that 3 will cancel 3. Then this 3 will also cancel this 3, which will give us, here will be 1. So 1 times 2, which is 2, then into brackets 3x minus 5. So we have that there. So 1 times 2, which is 2 into bracket 3x minus 5 plus 3 times 3 is 9. So 9 into bracket x plus 2. Then 3 will cancel itself here. So we are going to have 98. Now you see this becomes like type 3 of linear inequality. So you open the brackets and you simplify. So you are going to have 2 times 3x, which will give us 6x. 2 times minus 5 will give us minus 10. 9 times x will give us 9x. 9 times 2 will give us 18. It's greater than or equal to 98. So we group like terms. Luckily for us, both 6x and 9x are on this side. So we take the numbers to the other side. So 6x plus 9x greater than or equal to 98 is already here. Now 10 is negative. When it crosses to this side, it becomes positive. So plus 10. 18 is positive. When it crosses to that side, it becomes negative. So minus 18. 6x plus 9x will give us 15x. 98 plus 10 minus 18 will give us 90. From here, what do? We divide through by the number attached to the variable. So we divide through by 15. So we're going to have 15x divided by 15 greater than or equal to 90 divided by 15. 15 will cancel itself. So we are going to have x here. 90 divided by 15 will give us 6. So the solution to this inequality is x is greater than or equal to 6. Thank you very much for watching this video on linear inequalities. See you in the next video where we take another question on solving type 4 of linear inequalities. Bye-bye. We are still on the topic linear inequalities. In the previous video, we looked at an example on solving type 4 of linear inequalities. In this video, we are going to consider another example. So, let's look at the example for this video. The question given us is 1/2 into bracket x plus 3 plus 1/4 into bracket x minus 1 is greater than or equal to 1/3 into bracket x minus 2 plus 4. So as we've been doing in the previous videos, we said that whenever you have a fraction, the first thing you need to do is to first identify the fractions. So here the fractions in this question is 1 over 2, 1 over 4, and 1 over 3. Now there are no mixed numbers or mixed fractions, so there's no need converting anything here. So after you've identified the fractions, what you have to do is to find the LCM of the denominators. You find the LCM of the denominators. If you find LCM of 2, 4, and 3, you are going to get 12. As I said, I've explained how to find LCM in the videos on sets. So if you watch that video, you will know how to find the LCM of a set of numbers. So here, the LCM of 2, 4, and 3 is 12. Now, after you found the LCM, the next thing you need to do is to identify the terms in the inequality given to you. So here you have to identify the terms. Now, a term in this inequality will be separated by addition or subtraction. Between 1 over 2 and what is in the bracket, there is multiplication. There's no sign here, which means that they are multiplying. It means that this is one term. Okay, so this is one term. Now there's an addition sign here, so it means that the next one will also constitute another term. So here, this is also another term. Now when you come here, 1 over 3 and what is in the bracket here is also another term, and 4 is also another term. Don't forget that our LCM is 12. So you multiply each term by the LCM. I hope that is clear. You multiply each term by the LCM. This means that you are going to have 12 times the first term. So 12 times the first term, which is everything here, plus 12 times the second term, which is what you have here, 1 over 4 into bracket 2x minus 1. Then you bring your inequality sign, so greater than or equal to 12 times this term here. So 12 times 1 over 3 into bracket x minus 2 plus then 12 times this term here, which is 4. So I hope that's clear. You multiply, you first find the fractions, you find the LCM of the denominators, then you identify the terms, and you multiply each term by the denominator. Remember, in the question, you don't have to put these boxes around them. I just put the boxes there to explain to you what the terms are. So if you identify the terms, then you multiply each term by the LCM. You multiply each term by the LCM. So here we do our cancellation, which means that 2 will cancel 12 6 times. Now 4 will cancel 12 3 times. Then 3 will cancel 12 4 times. So the fractions are all cancelled out. Now we move on with our simplification. So we are going to have 6 times 1, then into bracket this, which is x plus 3. So 6 times 1 is 6. So x plus 3 into bracket will be there. 3 times 1 is 3. Then you bring the bracket 2x minus 1. Then you close the brackets, greater than 4 times 1 is 4. So into bracket x minus 2. 12 times 4 is 48. From here, it becomes type 3 of linear inequalities. So you open the brackets and you simplify. So you're going to have 6 times x, which is 6x. 6 times 3 is 18. 3 times 2x is 6x. 3 times minus 1 is minus 3. Greater than or equal to 4 times x is 4x. 4 times minus 2 is minus 8. So plus 48. You group like terms and you simplify. I'm going to keep the terms with x on the left hand side, then the terms without x on the right hand side, which means that I'll have to bring 4x from this side to that side. So I'm going to have 6x plus 6x, which is already here. 4x is positive, so when it crosses to this side, it becomes negative, so minus 4x. Greater than or equal to, I already have minus 8 here, plus 48 is also here. So I'm going to take 18, which is positive. I'll bring it to this side, becomes negative. 3 is negative. When it comes to this side, becomes positive. So we have 6x plus 6x minus 4x will give us 8x. Minus 8 plus 48 minus 18 plus 3 will give us 25. When you get here, you divide through by the number attached to x. So if you divide through by the number attached to x, that number is 8. So what this means is that 8 will cancel 8 to give us x. You have 25 over 8. Now this is an improper fraction, so you have to leave our answer in a mixed number. If you want to learn how to use your calculator to do that, I showed you in a previous video and I'm going to do it once again. So here the fraction is 25 divided by 8. So you enter that on your calculator, then you press equal to. Now if you press equal to, you see that it will be written at this side also. Now this is how to do the conversion. Press on shift, then you press this button, the button with S and D on it. If you press it, it will convert it from improper fraction to mixed number or mixed fraction for you. So that's going to be 3 whole number 1 over 8. So x will give us, the answer is x is greater than or equal to 3 whole number 1 over 8. So that is the answer to our question that we have here. Thank you for watching this video on linear inequalities. See you in the next video where we will consider another example on solving type 4 of linear inequalities. Bye bye. We are still on the topic linear inequalities. In the previous video, we solved an example on type 4 of linear inequalities. In this video, we are going to consider another example. So let's look at our questions for this video. We are being given 8x minus 3 over 2 minus 10x minus 6 over 4 minus 12x minus 1 over 12 greater than 4 whole number 1 over 12. So how do we solve this? As I said in the previous videos, the first thing you need to do is to identify the fractions. So here the fractions are this, which is 8x minus 3 divided by 2, 10x minus 6 divided by 4, 12x minus 1 divided by 2, and 4 whole number 1 over 12. So what you have to do here is that since we have a mixed number or mixed fraction, you have to first convert this to an improper fraction. So that's the first thing you need to do. So we have 8x minus 3 divided by 2 minus 10x minus 6 divided by 4 minus 12x minus 1 divided by 12. Then you convert this. We are going to have 12 times 4, which will give us 48, plus 1, that will be 49, divided by 12. If you watch the video on conversion of mixed fractions or mixed numbers to improper fractions, you understand this very, very well. Now, after you are done with this, the next step you need to do is to find the LCM of the denominators. The denominators in this case are 2, 4, 12, and 12. If you find the LCM of 2, 4, and 12, you are going to get 12. So the LCM of these numbers is 12. Now, what you have to do next is to identify the terms in the inequality. You have to find the terms in the inequality. As I said, terms are separated by either addition or subtraction. So here, the whole thing that you have together here, this fraction is a term. Now there's a subtraction here, so which means that the next one is also a term. So this is also a term. Then this one is also a term since it's being separated by subtraction. Then what you have on this side here is also a term. So we have 4 terms here. 1, 2, 3, 4. Now after you've identified the term, the next thing you need to do is to multiply each term by the LCM. So you are going to have this term here times 12, this term times 12, this term times 12, then this term times 12. Hope that is clear. So from here, we can move on to the simplification. Now, if you are simplifying, you will see that, if you are simplifying, you see that 2 will cancel 12 6 times, 4 will cancel 12 3 times, 12 will cancel 12 1, then 12 will also cancel 12 1. So we are going to have, since 2 is cancelling 12 6 times, we are going to have 6 times what is here. Now I'm putting that in a bracket because in the videos on multiplication of algebraic expression, we learned that whenever you have a single term multiplying a binomial, that is 2 terms, put the binomial in a bracket. Here, 8x minus 3 is a binomial, 6 is a single term. So if it's multiplying a binomial, you have to put the binomial, which is 8x minus 3, in a bracket. Once again, watch the video on multiplication of algebraic expressions and you understand very well why we are putting 8x minus 3 into a bracket. 4 will cancel itself 1 and cancel 12 3 times. So you have 3 into brackets, what you have here, which is 10x minus 6, minus 12 will cancel 12 1. So 1 times what you have here, which is 12x minus 1. Then 12 will cancel 12 1. So 1 times 49 will give us 49. From here, we open the bracket and we simplify. So we have 6 times 8x, which will give us 48x. 6 times 3 will give us 18, but it's negative, so minus 18. Minus 3 times 10x will give us minus 30x. Minus 3 times minus 6 will give us positive 18. Remember, when a negative number multiplies a negative number, you are going to get a positive number. Minus 1 times 12x will give us minus 12x. Once again, minus 1 times minus 1 give us positive 1. Then this one is greater than 49. So we group like terms and we simplify. In grouping like terms, you are going to have 48x minus 30x minus 12x greater than or equal to 49 plus 18 minus 18 minus 1. So we move on. 48x minus 30x minus 12x will give us 6x. 49 plus 18 minus 18 minus 1 will give us 48. When you get here, what do? You divide through by the number attached to the variable. The number attached to the variable is 6. So you divide through by 6. So 6 will cancel 6 to give us x. 48 divided by 6 will give us 8. So the answer to our question is x is greater than or equal to 8. Try and represent this answer on your number line and see if you'll be able to do it. Thank you for watching this video on linear inequalities. In the next video, we are going to learn how to solve the 5th type of linear inequalities. Bye-bye. We are still on the topic linear inequalities. In the previous video, we saw how to solve the 4th type of linear inequalities. In this video, we are going to consider how to solve the 5th type of linear inequalities. So let's look at the 5th type of linear inequalities. It is what we call the double inequalities. In this type of inequalities, you will have 2 inequality signs in the expression. So for example, in the first one, we have 2 inequality signs. In the second one, we have 2. And in the third one also, we have 2 inequality signs. We are going to solve the first example in this video. So we pick the first example. Minus 6 is less than x minus 2 and less than 4. Now when you have this, how do we do it? You are going to break the inequality into 2 parts, then you solve them one after the other. So we are going to pick the first part. Now this is the first part of the inequality. You pick from minus 6 up to this side. So you pick the term in the middle together with the first inequality sign. So from minus 6 is less than x minus 2. That is the first part of the inequality. You pick that, then you solve it. I hope that is clear. So the first part is minus 6 is less than x minus 2. Now you group like terms and simplify. This is what we are going to do. So I'm going to send minus 2 from this side to that side, so it's going to be positive. So I'll have minus 6 plus 2 is less than x, and this will give me minus 4 is less than x. So I've solved the first part of the inequality. I had minus 4 is less than x, or x is greater than minus 4. Okay, then we move on to, after you solve the first part, you move on to the second part of the inequality. You've seen that this is the first part. Which part will also constitute the second part? The second part, you pick it from the middle here up to the other inequality sign, just as we have here. So this is the second part of the inequality, which is x minus 2 is less than 4. X minus 2 is less than 4. So you solve this inequality too. In solving, we know that you are going to group like terms. So you are going to have x is less than 4 plus 2 and x is less than 6. So we've solved the inequality. We've broken them into two parts and we solve them one after the other. Now, to find the truth set or the solution set, you have to bring these two answers together. So here we know that x is less than minus 4, x is greater than minus 4, and x is less than 6. So to find the truth set, we say that s is such that, then you bring your first answer, which is minus 4 is less than x, so minus 4 less than x. Then you join it with your other answer or your second answer, which is x is less than 6. But because you already have x here, you are not going to write another x, so you bring less than 6. So you break the expression into two parts, you solve them. After solving, you bring your answers together. So we have x is such that x is greater than minus 4 and x is less than 6. This is an example of a set builder notation. If you watch the video on description of sets, you understand how members in this type of set are listed. I advise that you watch that video to get more knowledge about this. Now, this is the truth set. The question also told us to illustrate our answer on a number line. To illustrate your answer on a number line, this is what you do. You draw the number line in such a way that both ends of your answers appears on the number line. This is what I mean. The ends of our answers are negative 4 and 6. So you make sure that on your number line, you have negative 4 and 6 on the number line. So here we have negative 4 at the lower end, then we have 6 as the upper end. Now, what you do is that you draw a line from negative 4 to 6. So you draw a line from one end to the other. Then you draw a small circle on the ends. Now, because x is greater than negative 4, you are not going to shade the circle. If it were to be x is greater than or equal to negative 4, you would have shaded the circle. But because it's strictly greater than, you are not going to shade it. And also because x is strictly less than 6, you are not going to shade this circle too. Thank you for watching this video on linear inequalities. See you in the next video where we take another example on solving the fifth type of linear inequalities. Bye-bye. We are still on the topic linear inequalities. In the previous video, we saw how to solve the fifth type of linear inequalities and we took an example on it. In this video, we are going to consider another example. So let's look at this, the example we will be considering in this video. We have x minus 1 is less than or equal to 3x plus 1 is less than or equal to x plus 5. Just as we did in the previous video, in this video too, we are going to break this inequality into two parts. Then we solve the parts. After that, we will bring our answers together. So the first part of this inequality will be from minus x here up to the middle here. That will be covering the first inequality sign. So our first part of the inequality is x minus 1 is less than or equal to 3x plus 1. This is the first part of our inequality. So we solve for x. We know how to do this. We have been doing this all along. So we group like terms and we simplify. We are going to have x minus 3x is less than or equal to 1 plus 1. x minus 3x will give us minus x is less than or equal to 2. You divide through by negative 2. Now remember that as soon as you divide through by a negative number, the direction of the inequality sign is going to change. So if you divide through by negative 2, you are going to have negative 2x divided by negative 2 greater than or equal to 2 divided by negative 2. Now negative 2 cancel negative 2 to give us x. So we're going to have x is greater than or equal to 2 divided by negative 2 will give us negative 1. So you solve the first part of the inequality. What you do is that you go on and solve the second part of the inequality. So the second part of the inequality will be from 3x plus 1 up to the side that is covering the next inequality sign. So 3x plus 1 is less than or equal to x plus 5. So this will be the second part of our inequality. 3x plus 1 is less than or equal to x plus 5. Now you group like terms, then we simplify. You know how to do this already, so we are going to go through it quickly. We are going to have 3x minus x is less than or equal to 5 minus 1. 3x minus x will give us 2x is less than or equal to 5 minus 1 is 4. So we divide through by 2 and x is good. We are going to have x is less than or equal to 2. So we have our answers. X is greater than or equal to negative 1. X is less than or equal to 2. So we bring our two answers together. We bring the two answers together. Now in bringing the two answers together, this is what you do. So you are going to write the truth set. Now if you write the truth set, you make sure that the variable is always in the middle. The variable is always in the middle. So here the variable in question is x. So x is always in the middle. Don't forget that you draw your curly bracket, then you write s is such that. So these ones will be there. Your curly brackets will be there. Your s and this sign will also be there. So we are going to learn how to write this. Okay. So make sure that your variable is always in the middle. The variable in this question is x. So x is always in the middle here. Now look at this very well. The first part of our answer says that x is greater than or equal to negative 1. Now you can see from here that if you write x here, the greater than sign, x is greater than or equal to negative 1. So x is greater than or equal to negative 1. Always make sure that the smaller number comes first. The smaller number is called the lower limit. Make sure that the lower limit comes first. Between negative 1 and 2, negative 1 is the smallest. So make sure that negative 1 comes first. So you have your x here, you have negative 1 here. Now look at the symbol here. The symbol is that x is greater than negative 1. So it's going to turn like this. X is greater than negative 1. So you see that what you have here, x is greater than negative 1, is the same as what we have here. So that is the first part of our answer. I hope that is clear. So once again, I'm going to go over so that you get it. Make sure that the variable is always in the middle. So x is in the middle. This side will be the lower limit. This side will be the upper limit. So the lower limit is negative 1. So we have x is greater than or equal to negative 1 as we have here. Then you join it with your the second part of your answer, which is x is less than or equal to 2, just as we have here. So if you have your variable in the middle, your lower limit here, your upper limit here, make sure that the signs between them are the same as what you have in the question. So here, x is greater than or equal to negative 1, x is less than or equal to 2, just as you have here. So if you have a question like this with double inequality signs, you break the inequality into two parts. You solve each part. After that, you bring your two answers together. The question also said we should illustrate our answer on a number line. So you draw a number line such that the two answers will be on the number line. So here, negative 1 is here, 2 is also here. So I use the difference of 1. So from -1, I went to 0, 1, then 2. Now after you've done with this, you draw a line from -1 to 2. You draw a small circle on each of the answers. Now because x is greater than or equal to -1, you shade the circle on -1. And also because x is less than or equal to 2, you shade the circle on 2. Thank you for watching this video. See you in the next video where we will take another example on double inequalities. Bye bye. We are still on the topic linear inequalities. In the previous video, we considered an example on solving the fifth type of linear inequalities. In this video, we are going to consider another example. So let's look at the example we'll be considering in this video. We have -2 is less than 1/5 into bracket 2x minus 4. So how do we solve 2x minus 4 then less than or equal to 2? So how do we solve this? As we've been doing in the previous videos, when you have a double inequality like this, you break the inequalities into two, then you solve them one after the other. So we pick the first part of the inequality, which is -2 is less than 1/5 into bracket 2x minus 4. So we pick this part. So that is the first part of our inequality. -2 is less than 1/5 into bracket 2x minus 4. And we solve it. So we know how to solve this. We know that if you have an inequality that involves a fraction, the first thing you need to do is to first identify the fractions. So here there's only one fraction, which is 1/5. Now after you've identified the fraction, you find the LCM of the denominators. Since there is only one fraction, which is 1/5, the LCM is going to be the denominator of that fraction. The denominator of the fraction is 5. So here the LCM we are going to use is 5. Now after you've identified that also, you identify the terms in the expression. So here the terms are -2 and this whole expression, which is 1/5 to bracket 2x minus 4. So we've identified these two terms. Now what you do is that you multiply each term by the LCM that you found. The LCM is 5, so you multiply each term by 5. This means that you are going to have -2 by 5, then less than 5 times this term here, which is 1/5 into bracket 2x minus 4. If you watch the videos explaining how to solve inequality involving fractions, we explain this into details. So we are continuing. We are going to continue with this. So -2 times 5 will give us -10. 5 will cancel 5 to give us 1. So we have 1 times 1, that will be 1 into brackets 2x minus 4. So here we open the bracket. -2 is less than 1 times 2x will give us 2x. 1 times -4 will give us -4. We group like terms and we simplify. 2x is already here, so I'm not going to send it over there. I'm going to take 4 from this side and send it over there. So I have -10 here. Because 4 is negative here, when it crosses to this side, it becomes positive. So I'm going to have -10 plus 4, which will give us -6. It's less than 2x. What do you do here? We divide through by the number attached to the variable. The number attached to the variable is 2. So we divide -6 by 2 and we divide 2x by 2. So we are going to have -6 divided by 2 give us -3. 2x divided by 2 give us x. So x is less than, -3 is less than x, or x is greater than -3. So we've solved the first part of the inequality. Now let's move on to the second part of the inequality. So what is the second part of the inequality? Is the part that is contained the second inequality sign, which is this. So 1/5 into bracket 2x minus 4 is less than or equal to 2. That is the second part of our inequality. So you pick that one also and you solve it just as we did for the first part. So here let's solve it. We have identified the fraction to be 1/5. So the LCM is going to be 5, since that is the only fraction. This is one term, this is another term. You multiply each term by the LCM. So we are going to have 5 times 1 over 5 into bracket, sorry, 2x minus 4 less than or equal to 2 times 5. So this is the other term, so you multiply it by 5. 5 will cancel 5, so we are going to have 1 here. So this is going to give us, okay, this is going to give us 1 times 1, which is 1, into bracket 2x minus 4, then close the brackets, is less than or equal to 2 times 5 is 10. 1 times 2x will give us 2x, 1 times minus 4 will give us minus 4, is less than or equal to 10. We group like terms and simplify. So we have 2x is less than or equal to 10 plus 4. 2x is less than or equal to 10 plus 4 is 14. So here we divide through by the number attached to x, which is 2. You divide through by 2, and you are going to have 2x divided by 2. Then you have your less than or equal to sign, 14 divided by 2, and x is less than or equal to 7. So here we have x is greater than negative 3 and x is less than or equal to 7. We have our two answers here. So what do you do? If you have your two answers here, then we need to represent this on our number line. First, we need to find the truth set. So to find the truth set, we say that the truth set is given by S is such that, then as I said, you'd write the variable in the middle. So you write the variable in the middle here. You write the lower limit here. You write the upper limit here. So x is greater than negative 3. The lower limit is negative 3. So you write it here. So x is greater than negative 3. Just as we have in the answer here. Then you bring the second part. The second part is that x is less than or equal to 7. So since you already have x here, you bring your less than or equal to sign, then 7. So this is the truth set. From here, you represent your answer on a number line. So to represent our answer on a number line, we draw the number line in such a way that the ends are on the number line. The ends of the two numbers are on the number of the answers are on the number line. So here our answer is negative 3 and 7. So we make sure that negative 3 and 7, those two numbers in the answer, you make sure that they are on the number line. Then you draw a line from negative 3 to 7. After that, you draw a small circle on negative 3 and 7. Now, because x is strictly greater than negative 3, you are not going to shade the circle on negative 3. But when you come here, x is less than or equal to 7, which means that you are going to shade 7. 7 is included, so you are going to shade 7. Thank you for watching this video on the fifth type of linear equations. Pick more examples and try your hands on them. If you have any problems, you can interact with me on my social media handles and I'll help you to solve the question. See you in the next video where we will consider word problems that involve the use of inequalities. Bye-bye. We are still on the topic linear inequalities. In the previous video, we learned how to solve the fifth type of linear inequalities. In this video, we are going to learn how to solve word problems that involve the use of linear inequalities. So let's pick some examples and see how this is done. We have about 3 questions here. We will solve them one after the other. Take note of these questions. We will solve the first one in this video, then we will solve the other 2 in the subsequent videos. So let's pick the first one. It says that when thrice a certain number is added to 5, the result is more than 17. What is the range of values of the number? Now you can see from here that the question is not telling us to find the number. It's telling us to find the range of values, because for inequalities, you are going to get a range of values. You are going to get a lot of values. So that's what the question will be telling you to find, a range of values. So let's consider the question very carefully. When thrice a number is added to 5. The result is more than 17. What this means is that thrice a number means 3 times a number. Thrice a number, it means 3 times a number. So when 3 times a certain number is added to 5, the result is more than 17. You are supposed to find the range of values for the number. So let's begin. This is our solution. So we are going to, since we don't know the number and that is what we want to find, we are going to say that let the number be u. So we are representing that number, that the number that we want to find, we are representing it with b. Sorry. So we are going to let the number be equal to b. So we now know the number as b. Let's read the question again. It says that thrice a certain number. The number is now b. So it means that 3 times that number, 3 times b, is added to 5. So thrice the number is added to 5 means that you are going to have 3 times b plus 5. 3 times b is 3b. So you are going to have 3b plus 5. So we've now written the expression for the first part, which is thrice a certain number is added to 5. We've now let the number to be equal to b. So 3 times b is added to 5. So 3b plus 5. The question goes on to say that the result, this result, which is 3b plus 5, is more than 17. When we say something is more than 17, it means that that thing is greater than 17. So what this means is that this result here, 3b plus 5, is more than 17. What that means is that 3b plus 5 is greater than 17. So you see, it's very simple. We have now written the linear inequality. So from here, we can solve this linear inequality for b. So I'm going to go through the process again so that you get it very well. Okay, I'm going to clean all the ink here. It says that 3 times a certain number is added to 5. We don't know the number, so we represent that number by b. You can choose any variable. Now, 3 times that number means you are going to have 3b or 3 times b. The question says that 3 times that number is added to 5. So 3 times b plus 5. Then the result is more than 17. The result is 3b plus 5. This result here is more than 17, which means that 3b plus 5 is greater than 17. So 3b plus 5 is greater than 17 as we have here. So we can now solve this. We know that 3b plus 5 is greater than 17. If you are solving this, you are going to have 3b is greater than 17 minus 5. 3b will be greater than 12. We divide both sides by 3, as we've been doing all along, and b will be greater than 4. So the range of values is that b is greater than 4. So any number that is greater than 4 will satisfy the condition that was given to us. So b greater than 4, which means that we can now say that therefore the number is greater than 4. So any number greater than 4 will fit the condition that was given to us. So that is the range of values to satisfy the expression in the question that was given to us. Thank you for watching this video. See you in the next video, where we will take another example on word problems that involve the use of linear inequalities. Bye-bye. We are still on the topic linear inequalities. In the previous video, we took an example on word problems that involve the use of linear inequalities. In this video, we are going to consider another example. So let's look at our question for this video. When 5 is added to 4 times a certain number, the result is not more than twice that number added to 19. What is the range of values of the number? So you see, for inequalities, they will always be telling us to find the range of values. That is what we are interested in, the range of values, the set of values. Okay, so here, to find the range of values, you will have to write the inequality for this expression or for this statement that has been given to us. The question is talking about a certain number. We don't know the number. So the first thing you need to do is to let a variable represent the number. So we are going to say that let the number be equal to x. So the number, we are going to say that the number is equal to x. So we are letting the number to be equal to x. So here we know the number. We don't know the actual number in a sense, but we have represented it by x. Okay, now let's move on and solve the question. The first part of the question says that 5 is added to 4 times a certain number. So in this case, the number is now x. So 5 is added to 4 times the number. 5 is added to 4 times the number. This means that you are going to have 5 plus 4 times the number, which is x. 4 times x is 4x. So that's the first part of the question. 5 is added to 4 times a certain number. The certain number now, the number now is x. So 5 is added to 4 times x. 4 times x is 4x. So 5 plus 4x. Let's move on to the second part. It says that the resource is not more than twice that number added to 19. Let's take it one after the other. The resource, what resource is it talking about? This is the resource, 5 plus 4x. When 5 is added 4 times a certain number, the resource, so the resource in this case is 5 plus 4x. That's why the question is saying that, is telling us that the resource is not more than. Let's concentrate on that. The resource is not more than. Is not more than. Now let's say that I tell you that I am not older than you. What does it mean? I am not older than you. That means that I am either the same age as you, we are the same age, or my age is smaller or lesser than your age. So my age is less than or equal to your age. If I tell you I am not older than you, what it means is that my age is the same as yours, or my age is less than your age. So this statement, the result is not more than. What that means is that this result here is not more than, is less than or equal to twice that number added to 19. That number is now x. So twice that number will be 2x. Added to 19 will be 2x plus 2. So all that this statement is telling us that 5 plus 4x is not more than, which means that it is less than or equal to twice that number added to 19. Twice that number is 2x, added to 19 is plus 19. So I hope that is clear. Let's go through it again. 5 is added to 4 times a certain number. So 5 plus 4x. The result is not more than. Whenever you hear the statement it's not more than, it means that it is less than or equal to. It's not more than, so it means that it is less than or equal to. The result is not more than twice that number added to 19. That number is now x, so twice that number will be 2x added to 19, so plus 19. So the expression that we are supposed to solve in order to get our answer is 5 plus 4x is less than or equal to 2x plus 19. So let's solve this expression. What do? Since we have this linear inequality, you group like terms and you simplify. So we have 4x minus 2x is less than or equal to 19 minus 5. 2x is less than or equal to 14. You divide both sides by 2 and you are going to get x is less than or equal to 7. So we can say that the number is less than or equal to 7. So any number that is less than or equal to 7 will satisfy the condition that was given to us in the question. Thank you for watching this video. See you in the next video where we will solve another example on word problem that involve the use of linear inequalities. Bye-bye. We are still on the topic linear inequalities. This will be the last video on linear inequalities. In the previous videos, we've learned how to solve word problems that involve the use of inequalities. In this video, we are going to consider the last example. So let's look at our question for this video. It says that 4 is added to 3 times a certain number. 4 is added to 3 times a certain number. The result is at least twice that number added to 10. Find the possible range of values of the number or for the number. So here we are talking about a certain number. We don't know that number, so we represent that by a variable. So I'm going to let x be the number. So the number is equal to x now. Now let's break the statement down and find the inequality. Then we solve it in order to find x. The first part of our statement is that 4 is added to 3 times a certain number. We now know that that number is x. So 4 is added to 3 times x. And that will give us 4 plus 3x. Since 3 times x is 3x. Let's move on to the next part. The result. The result is now 4 plus 3x. So this result, 4 plus 3x. This is the result that is talking about. This result, 4 plus 3x, is at least twice that number added to x, added to 10, sorry. It's at least twice that number added to 10. So the statement at least is playing a major role here. Now, which inequality sign are you going to use for this statement? At least. When I tell you that, give me at least 2 books, what does it mean? At least 2 books. That means that 2 or more books, or 2 greater than or equal to 2 books. So when I tell you to give me at least 2 books, I mean 2 or more books. Mathematically, that means greater than or equal to 2 books. So whenever you see the statement at least, the inequality sign you are going to use is greater than or equal to, because at least means that it's greater than or equal to what you are talking about. So here, the statement says that 4 plus 3x is at least twice that number. That number is now x. So at least twice x added to 10. So the result is at least twice that number added to 10, which means that 4 plus 3x is greater than or equal to twice that number. That number is now x, so twice x, which is 2x, added to 10 plus 10. I'm going to go over it once again so that you get how we got to this point. Okay, so 4 is added to 3 times a certain number. We have represented that number by x. So 4 plus 3x. The result is at least, as I said, when you hear at least, it means that it's greater than or equal to. So at least twice that number added to 10. That number is x. So at least twice that number added to 10 means that greater than or equal to 2 times x, which is 2x, added to 10 plus 10. So we have 4 plus 3x greater than or equal to 2x plus 10. We now have our inequality. Now we are going to solve it. So 4 plus 3x is greater than or equal to 2x plus 10. We group like terms. So 3x and 2x will be on one side. 4 and 10 will be on the other side. So I'm going to send all the terms with x on the left hand side, then the ones without x on the right hand side. So I'm going to have 3x minus 2x is greater than or equal to 10 minus 4. 3x minus 2x will give us x. So x is greater than or equal to 10 minus 4 is 6, which means that we are having x is greater than or equal to 6. That means that the number is greater than or equal to 6. So any number greater than or equal to 6 will satisfy the condition that was given to us in the question. So the range of values are numbers that are greater than or equal to 6. Thank you for watching this video and all the videos on linear equations and linear inequalities. There are a lot of examples for you to solve. Try your hands on these examples from your textbooks. Solve more questions. If you have any problems, interact with me on my social media handles and I'll help you to solve the questions. Bye bye.